Hello there, ladies, gentlemen, and unicorns. Can you hear me? First question. Yes, apparently you can. How are you all doing? I'm doing not so well today. I fear that I have an onset of a headache somewhere behind my eyeballs. It's just this tiny little sting, but yeah, either it will get worse much quicker, or it will vanish because we're having so much fun programming. Hello everyone. Hello, Tutvari is here. Frank, of course, is here. Congratulations, Frank, on winning the quiz. By now, you probably also have memorized most of these questions. And yes, you are absolutely right. 3-1 is nothing in binary. That's probably decimal. So maybe I should rephrase the question, as with so many questions. The phrasing is a little bit off because I overthink things, and then the phrasing comes off as kind of weird, and then it's ambiguous as well. So, point noted. Maxi TB is here. Hello, Maxi, and Mr. Troy. Thank you so much for subscribing. Wonderful of you to join today. I love you all. I'm here too. That's so nice. Thank you. We love you back, Mr. Troy. This is so nice, so wholesome of you to drop by. The question is perfectly clear. Okay, at least. So then the answers are wrong. Maxi says, I find it funny that I'm even on the scoreboard answering a single question. Yeah, it depends. As always, this is what they told us when I was in film school. When I said, yeah, one day maybe I win a festival prize with my film. And the teacher said, there are so many film festivals out there, and chances are if you partake in all of them or most of them, maybe there is no competition and you win, I don't know, the grand prize of Buenos Aires or something, because probably not Buenos Aires, but with let's say smaller film festivals, there are chances. And I think the quiz is the same thing, especially when you drop by early here. Chances are that the competition is not as fierce as one would think. Right, Cursibu, of course, how could I have missed you? And David Borland, wonderful name. When I hear Borland, I think of two things. Thing number one is C++ or C or Turbo Pascal in DOS, and the other is of Home Improvement. What was his name? Al Borland. So thank you so much for dropping by. I now imagine a guy with a beard and plaid shirt just typing away in the wonderful blue background of Turbo Pascal. The Borland pig, never heard of this before, I have to say. Of the compiler fame, exactly. Thank you for visiting and dropping by, Mr. Borland. Right, so which brings us perfectly is a wonderful segue to our topic today. As you can see, or probably not see, maybe I should zoom in a little. So what's going on here? Yes, I think it should be large enough for you to follow along. So today, I think last week I introduced you to my setup with VS Code and compiling or writing DOS code, Pascal code, free Pascal as it is, and compiling to DOS. And it's working. And last week I showed you that it's working, and I showed you some of my text experiments. But since then I thought, you know what? Graphics would be nice, and we're talking about VGA graphics. And so I did some tests, and of course, if you follow me on the socials, you probably have maybe followed some of my posts there, where it was like, yay, I got a pixel on screen. Next one is, oh my god, why is this so slow? And yeah, I will walk you through my code that I have, and then let's continue to work on one of my problems that I'm currently having. Frank says 2025 is definitely the year of Pascal. Oh, please let us know why. Again, I feel I'm out of the loop. Why is 2025 the year of Pascal? David Wallen says, oh, what's the logo in the upper left? This one here. Yeah, this is VS Code. So as far as I understand it, this is a fork of, this is VS Codium, and it's a fork of VS Code without the stupid Copilot button that usually is here. So this is the thing with everything Microsoft stripped from it, and yeah, I've converted over a couple of weeks back, and so far I kind of like it. Also, the good thing is also you got some extensions here. So essentially, the experience is pretty much the same, unless, of course, there are certain extensions that you don't find here, but most of them should be here. Then what else? Maxi says, oh, I guess it's been a while the Borland pig was their mascot. Oh, never heard of this. Still got one lying around after I got one at a convention decades ago. Oh, this is so nice that they had a little pig apparently as a logo. That's so random. And Kersey cracks the debugging knuckles. Yeah, we will need them. We will need them. I mean, since we're already looking at hex codes, so on, so you can probably guess that we're a little bit more low level than usual today. I mean, it's not been the year of Pascal for a while now, so it's overdue. Indeed, I don't remember. I think the last year of something I I was aware of was the year of Luigi. Thank you, Nintendo. And I think, wasn't it last year where people also said maybe that should better be the year of Luigi? Yeah. David Borland approves. And Mr. Troy says, "Woo, I need that in my life." Yeah, I can. So far, it's like the Android phones with everything Google stripped from them. I mean, that's for me not possible because I've sold my soul to them a long time ago. But for VS Codium, again, look for VS Codium. I think it's on GitHub. And the cool thing about it is, at least how I migrated over to it. When you have your VS Code user folder, essentially if you just copy it over to VS Codium, I think some of the extensions don't work, but all your preferences and everything, how you set things up, should in theory work. At least it works for me well enough that I could just keep on coding. So yeah, this has been my public service announcement. Yeah, open source software is the greatest. And also, I mean, it feels just more more welcoming, because the other VS Code, I feel like as soon as they started trying to get this Copilot thing and you have to sign in with your Microsoft account and so on and so forth. Yeah, this VS Codium, it's a portable installation which lives in my Dropbox. So whenever I switch on another device, Dropbox syncs, and I'm even there. I think it even saves the layout that I had my Windows and my Fuse on. So if the paths on your other machines are pretty much the same, you should be good. So again, from my end, I can't recommend this enough. Right. MaxiTP says, noise VS Code without Copilot is something everyone needs. It's actually not little and long like a Wiener dog. So the you mean the Borland pig? Performance is everything, says Frank. Oh yes, we will get into this. And Maxi found it's actually not that long. Okay, so it's not Long Cat, the pig version. Kersey says, year of Linux desktop someday. We probably won't take that much longer. And Maxi Debate says, wow, the PCX format, another blast from the past. Yeah, that's the thing. I mean, we can take a look at my DOS game here, but first I want to show you my journey there. So I have a couple here of, as it were, of Graph 1A, Graph 1B, and those are different attempts of me doing graphics. So let's compile here the first one and see what this does. And essentially here, as you can see, it just draws a little pixely ball that bounces off the frame. The thing is, I mean, this is running here in DOSBox X at 100% speed, which means on actual DOS machines this will run so much slower. And you can say here emulate CPU speed, and let's go for a 386 with 33 megs, and suddenly, yeah, you see how fast this actually would be running on DOS. So what is going on here? Why is this thing so utterly slow? And yeah, this brings us to good old DOS and hardware stuff. And by the way, one book, where do I have it, that I can already recommend right off the bat when you're interested in old DOS hardware and software is, let's switch over, is The Game Engine Black Book by there it is, Fabian Sanglar, who also wrote the Doom Black Book, which I have somewhere back there. The cool thing about this is this chronicles and not just the development of Wolfenstein 3D, but also the entire surroundings, like what was the hardware situation at the time, what was the software situation at the time, what were the editors, who was the team. And so, for example, the book starts off, I have to keep it slanted, otherwise it's overexposed, but just how fast were CPUs back in the day. And what were the problems with DOS memory, where we have all the real mode and the protected mode, and paging in different memory segments for advanced memory things, the first graphics cards, and also how graphics were done in DOS. And again, this is exactly what's happening here. The problems that we're facing are because you need, if you want to write many pixels to screen, in this case I'm using the VGA mode, so it's 320 pixels across and 200 vertically. So this means an awful lot of pixels, and if you want to write this like around 70 times per second, back in the day no RAM was fast enough to supply enough data for the pixels to be plotted. So instead what they did was not having one bank of RAM where just everything was sequential, but they had like 4 pages. And the thing, what makes it even worse or harder to program is instead of reading a byte or from one page, it's reading a bit of one page. So for example, if you have a nibble, so that's half a byte, so it reads the first bit from page 1, the second bit from page 2, and so on. And again, this makes it hard to store things, because you need like when you need to mask things out, it takes like probably 12 commands to and writes and reads and so on. So again, it's super slow. The Carmax of this world and the Michael Abrash, as is outlined in the Game Engine Black Book, they found a way of doing things faster, but still this is not what I'm doing. Instead, what I'm doing is, and what makes this so slow is that I'm writing all the pixels that I have to memory, and once when the screen is ready to be updated, or the screen just has updated essentially, I write everything that's currently happening, the entire memory, pixel by pixel, I copy it into the video buffer. And this is what's making this so slow, because I'm writing essentially with every frame, essentially, I'm copying the entire graphics buffer that I have to the graphics memory. Also, if you want to know how graphics works, is why I'm having a buffer and what graphics memory is. So this is the unified memory model. So essentially the graphics card, what it does if you want to send some pixels to the graphics card, is you put it in a special part of the memory. In our case, it's starting at, where do I have it? In VGA mode, it's starting at a certain memory offset. So there it is at A000 in RAM. So everything there gets read, each frame, whatever is there gets interpreted as pixels and color values and put on the screen. So, and of course, if you while the screen is being plotted and you put data there, suddenly, depending on where currently the graphics card is rendering out the pixels onto your screen, it could happen that you just add pixels that weren't there. For example, if you draw a sprite, or let's say a circle, and but the drawing has already been halfway through this one frame on the screen, suddenly you get tearing. So essentially this means whatever you manage to throw on the screen just appears at a certain point. So instead, what I'm doing is I'm doing page flipping, as it were. So this means I'm write everything to a memory address, So I make the entire picture. In our case, it's just I have this little dot and advance it to the next frame. And once my picture is constructed, I copy everything what is in this buffer over to this address A000, which then the graphics card reads. It's not the fastest thing that you can do, but also what makes it so slow is, again, that I'm doing this for all pixels for every frame. And I have here another program which essentially does the same thing, but if I switch over here from the CPU type again, let's emulate here CPU. I had here the 386 with 33 megahertz, and suddenly this is a lot faster compared to what we had before. And this is, I'm using a different method to copy the data from my buffer onto the memory of where the VGA card expects it. So essentially this is what's happening here. I'm setting the colors. Let me just quickly see where I have everything. Yeah, this is when I'm clearing the graphics buffer. Clearing means I just write 1 byte in there, and this is this dark blue background. So I'm using here a function that is called fill dword, and this, before that I was copying it essentially byte by byte. I'm just going through a loop, and for every byte until a certain offset has been reached, so all the pixels on the screen, then I'm done. If I do a fill dword, this is on a 386 actually faster because I can write 2 bytes at a time, and this is essentially what is happening here. Or in this case, since it's a dword, a double word, I'm even filling it with 4 bytes at a time. So of course this speeds things up a little bit. So what else have I missed in the chat? I'm sorry, I've been monologuing as well. PCX format, this is awesome, says David Borland. Thank you. Oh yeah, that looks more realistically. And Frank says, all you need is a tiny bit of optimization. Yeah, DOS gaming is all about optimizing things. And yeah, you've got the Doom one. Excellent books, indeed. Even better that you can use it with the OSS engine code it released. Oh, I didn't know this. That's nice. Max says, well, I've been around these times, so yeah, you know what's happening. And Commander Stitch is here. Hello, Commander. He says, it's huge. Frank says, debug output from my current code. Total evaluated moves, a big number, and moves evaluated per second. Wow, this is also a big number. I also care about speed. Yeah, for those who don't know, Frank is currently running his own, what is it, a chess engine that you write in C and have been keeping optimizing for 2 weeks now. And like I said, I don't understand C and even less about chess, but congratulations on apparently this is a big number. Max says the copying is also the worst way to copy memory to be. Exactly. What I'm doing is, again, I'm really just copying byte by byte and moving it. There are different ways of how you can cheat your way around this. So essentially is, the gist of it is try to update as little pixels as possible. You just really, you don't want to redraw the screen, or only if you really have to. And these are the optimizations that I then started here. Was it here already? Where I introduced something that is called the dirty rectangle thing. And there it is, dirty rects. So essentially instead, let's run this and then we can compare the metrics on this. So let's go for the 386 again. And look at this. This is the 386, and suddenly it's running in real time, relatively speaking, as fast as it should. So what has changed? Again, I'm not copying all the pixels. I'm only copying the pixels that need to be redrawn. And how do I do this? I'm using, as I said, dirty rectangles. So essentially, whenever I'm drawing something, patch different rectangles. In this case, I think it's even a rather simple implementation. So this is my main loop here. So in this, I'm drawing a sprite. And so this is, before that, I just said, hey, color these pixels in a certain color. For this demo, I'm already using a sprite. By the way, there is no support for hardware sprites. When I'm talking about sprites, I have to manage them myself, because again, all the graphics card, the graphics adapter essentially knows about is, okay, this is the memory with the pixels to plot. That's it. If I want sprites or some way of transparency, I have to do this all in software. And what I'm doing here with these dirty rectangles is I'm drawing the sprite at a certain position. Let's see, where is draw sprite? So I'm drawing a sprite at a certain X and Y coordinate. And what happens here is I'm checking if the sprite has changed. So if the X and Y coordinate are different from what they were before. So I'm storing, after every time I draw a sprite, I'm storing where it was drawn before. So if this has changed, then I mark out certain portions of the screen, as you can see here, marked dirty, where it was before and where it goes to next. And I'm adding here some padding by -1. So essentially I'm just saying with make dirty, I'm setting two rectangles where it was before and where it is now. And these are essentially the pixels that need to be plotted or replotted. Everything else can just stay in the memory that the graphics card, the graphics adapter reads from. And this makes it so fast. So instead of updating 200 by 320 pixels every frame, I'm updating in this case like 32 pixels, or even 16 pixels. And this makes it so fast. Of course, there are other ways where you can deplanarize your graphics adapter. So instead of writing or of having these four individual planes that get, I'm having troubles trying to explain it. But essentially, if you are one of the Carmacks or Michael Abrashes of this world, there are different ways of addressing the individual bits and bytes, or how the graphics adapter reads these bytes. Because of course there are certain cases where when you read something from the graphics adapter, and inside the graphics there is a latch, and this you can use for the next write to this pixel and so on. So I'm not getting into this because I'm very bad at explaining this, but essentially I'm using none of the advanced tricks. My only trick is try to plot as little pixels as possible. Right, let's see the excellent books. Copying is also the worst part to copy. Yes. Pascal does bound checks for every byte. Oh, really does it? So, yeah, again, it's the more low level you get, of course, the more you get out of it. I don't know any assembly myself, because with 86 assembly, I mean, I know a little bit of 6502 assembly, but that's just from dabbling with NES programming. So all the assembly that you can see here is setting the VGA mode and setting the text mode. I mean, of course, this is copied together from the stuff that I found online. So I'm not really understanding why I'm putting 0 here in the AH register, and then 13, and then calling interrupt 10H. I don't know why, but it's essentially just setting up the graphics adapter for VGA. In my case, it's 256 indexed colors in a resolution of 320 by 280. No, not 280, 320 by 200, and it gets stretched to a 4:3 aspect ratio. David Warland says, have you thought about using dirty Rex XA and only rendering? Yes, I have. No built-in mem copy, says Cursiboo. I think there is something that is in where you can just say move, but the thing is, it only, again with Pascal and in programming, I'm not really that well versed. This is just what I pieced together within 1 week. There is a move command where I can copy a part of a memory to another part and just say, yeah, just copy these, I don't know, X amount of bytes. And the thing is, I think I'm using a far pointer, and the compiler said this is not possible, and I didn't find another way around it. So essentially, I just rolled my own things of how I was doing it. But coming from things like Game Maker and Godot, suddenly having to worry about pointers and memory management, this has really been something different for me. And also, I'm reading PCX files, which again was something that I really had to wrap my head around, and this also took me a while that I could get it done. Because I mean, if I'm reading a PCX file, essentially what I'm really doing is I'm not using a library or anything. I read the file into memory and then parse what is every single byte that is in memory, and then write my own data structure from this that I then can interpret as pixels, essentially, and then write from the memory where the image, or in this case, as I call it, the sprite is stored. Then I'm writing it into the screen buffer, and then the screen buffer to the screen, but only in the dirty rects. Right, Maxi says to Kersey, not as far as I can remember, you had to use inline assembler. You're right, if you wanted to get around bound checks. Yeah, that's the thing. I think this kind of bound checks was keeping me in check. Well, when it comes to planes, there is also mode X. Exactly, this is what I was talking about. But I guess now we get into advanced stuff. Yeah, and mode Y and mode X. This is when you deplane essentially the VGA, which also means that you have to write masks, because now you have to tell yourself into which of these planes you want a byte or a bit actually to be copied, and there are certain speed ups. But again, this is all very occult knowledge, and I mean it's very well documented, especially in these black books there. But again, it's really something that I thought, yeah, I'm just content with the four, what's it called, the four latch write? No, it's not the four latch write. It's where essentially you cut off a lot of the memory that is accessible in graphics, but it's just easier to program. And I thought, you know what, easier to program, that sounds good with me. Hang on, what's it called? Of course, I cannot find it when I need it. RAM, memory manager, masking pages. Oh, the chain 4. Yeah, I think, by the way, this book is, I think, free online, at least, unless of course you want the printed version, which of course I have. But I think you can find everything that is in there. But again, it's just nice having it in a book that you can page through. Frank says, my experience was always that if you want to do random memory stuff, C is easier than Pascal. Of course, the question is why you want to do random memory stuff. Yeah, I thought, now that I get Pascal running, I'm trying to get as far as I can with Pascal. Max says, so yeah, every read-write into Pascal array is super slow, takes about 5 times the amount of time it should without bound checking. Yeah, and again, all these things under DOS, they really add up, and it's not something with today's machines where you go like, yeah, I worry about optimization later. Here you have to worry about it right away, I think. And when it comes to planes, yeah, that is mode X. Why did my emoticon end up in the middle of the message? I don't know either. Curses says, memory management can be a pain. Good to have an abstraction to help you out. Yeah, the biggest problem that I'm having right now is I wanted to do some text rendering there. And of course, this means text rendering is not as easy, especially if you're running all your graphics yourself. Usually you would just say, yeah, just print some text there. A library will handle this. In my case, what I started to do is to have a big sprite atlas of all the characters. Then I need to read the image, then split up the characters and store them somewhere and have pointers to where I store them. And when I request a certain character that is from a string, then I look up, okay, where in memory is this character, and then plot the pixels. So this is what I'm currently working on. Frank says, I can help you with the square is in check function in my code. Oh, of course. I mean, at least you got the squares down. with your chess engine. Frank says it's also going to depend on the compiler. Yeah, that's the next thing. A lot of bounce checking can be done at compile time in principle, but modern compilers are much better at that sort of thing than 80s and 90s stuff. I don't know about free Pascal. So the compiler, I think, is relatively new, because when I'm compiling, every time I'm compiling, I write out here a log file, and in the log file you can see something like free Pascal compiler version 3.2.2 from 2021 for the i386. So this, I would assume, is already a very good and optimized compiler compared to what Borland put out in the 80s. No offense. Cursor says for string/arrays you can do a custom I have no idea how to pronounce this, RAII vector if there isn't one. For arrays I'm doing this already because I can show you the latest incarnation of my program with everything like dirty rectangles and so on implemented, and yes, it's this. And when I switch over from, no, that's the scaler, where is the CPU, emulates the CPU speed. So again, 386 DX, I didn't click it, and again the ball bounces as it should. And by the way, this is a VGA mode, but I'm only displaying the first 16 colors for my artworks because this comes down to aesthetics. So the palette that I load are just the default EGA colors, and I'm having everything indexed with the EGA colors. But again, yeah, this is using all these tricks that I have, also including having a transparency color. So when we, for example, look at the PCX file of the ball, of course it's square, not round, and everything that should be transparent is the good old fuchsia color, that is this bright pink that we see. Sure, it's a recent release, but how modern is it? Yeah, that's the thing. From the architecture side, I have no idea, but as far as I understand, it should be somewhere open that one who understands it can look into it, but probably it's not going to be me. Maxi says, I wonder if the book is still around, which taught me a lot of graphic stuff back in the 90s. It was called CPU Underground or something. Okay, I've never heard of this. I only know of Michael Abrash's Advanced Graphics Programming, which is to my understanding, I've never had it, but to my understanding it was like the Bible of doing anything with DOS. Frank says the website says it's an advanced compiler. Okay, so all good. Thank you for checking then. Right, and so this was here my graphics G test, and this is here all in one big program. And so at a certain point I thought, you know what, probably I should compartmentalize this out into units, Pascal units. So essentially when I have here now a unit where just my globals are in there, in this case it's just the directories where the engine should look for things. Then here PCX, this is my unit to load a PCX file and return a file type of PCX. In this case, it would be T is the type and P is the pointer to this instance, essentially. So we're already in pointer territory. And what I started now is doing this pixel font. So essentially, how does it work when you start? I have, for all my drawing functions, I have, for example, here background from image just creates a PCX image from a file name. So essentially it loads a PCX file, and here with background I have a distinction between background and sprite. So the background does no checkings for is it inside the currently being displayed, or is the camera somewhere moving, or is it cut off on one side? It's not doing none of these checks. It always assumes that the file length is exactly the screen size or the amount of bytes there are, and there aren't any transparent colors. So this just speeds up drawing, because here for the sprites we're checking, okay, is the sprite being cut off on one side of the outside of the screen display area, because then we probably shouldn't be trying to draw these pixels and so on and so forth. So here the debug font is just something that I load, and here set VGA mode. This again is just like 3 lines of assembly that tell it to switch over from text mode to the VGA mode. Then here is something that is not working. I'm going to set the palette from a file, and I'm trying to parsing here the Microsoft palette file, which I think is also in Paintbrush or something. It's not working, so there's just some code there. I'm sorry. I just realized it that I'm not too well. Right. Maxi says it's a Databacker book. I think it's no longer available. We're talking 386 days here, and it was a very basic book, which not much underground stuff going on. Yeah, if it's Databacker, I think this is in German a very, let's say, established and somewhat a bit of a stuffy publisher. So yeah, and Jiří Hezek is here. Hey there, Pascal, cool. So indeed, it is very old school. So what I'm doing here is just trying to put characters in there. God, okay, maybe I should cut the stream for today at some point, because I'm really not feeling well. So the little migraine that I mentioned is returning with a vengeance, and I think I'm developing a fever right now. So let's start this again. So the characters you're seeing that I'm trying to render are on the top left part of the image here. So something is not working there, but there is a slight darker gray pixel, which is good because this was of some debugging going on. Oh God, I'm really not feeling well. I'm really sorry. I think I have to cut it. Did the migraine start before you opened the Pascal file? Yes, it did. But that's a good point. Yeah, about these dirty rectangles, I can show you just really quickly how this works, because if I do not fill the VGA buffer here with the background image when I start it, then the buffer is uninitialized and you get whatever is currently in memory at this position. In this case, you see I loaded my PCX file there. So this is why it is halfway loaded there. But essentially, wherever the ball goes, only then it updates what actually should go there. And also the draw background function. Yes, we can leave this. So here in my repeat loop, I'm just checking here for any input keys, which is not working right now. The logic is just when the ball should rebound and then play a sound. We wait for the retrace of the VGA. And when I say draw sprite, I'm drawing the sprite, but it creates this dirty rectangle. And then I'm only going to patch the screen from the VGA buffer. So I'm not going to fill it entirely. I'm just patching the dirty rectangles there. And once this has been done and been displayed on screen, so this essentially just patches it on the screen to whatever is being shown on the screen. And right afterwards, I'm patching the background again with the background image. Okay, I think I have to cut it. I'm sorry. Please finish if not healthy, says Cursey-Boo. Yes, I will. Don't stream with a headache. It's not worth it. I thought it might go away, but it's only gotten worse, so I'm really sorry. You know, headaches get worse when you look into a screen, in my experience. Yeah, should get some rest. Anyway, have some rest, Phil. No need to push it. I thought we can do some nice, fun DOS coding on stream, but yeah, I'm really sorry. Yeah, and even starting pushing the wrong buttons on my Stream Deck. Trying is fine, but if the headache is stubborn, yes, it is. And I'm also feeling my stomach is somehow upset now. I'm getting the sweats. I think I've caught a bug myself, and this time it's not even a programming bug for today. DOS ain't running anyway. It's fine. Thank you all for being so nice. Maybe I'm not sure if I feel better tomorrow, because maybe then I can pick up. Otherwise, it will be next week on Sunday. And again, yeah, I'm sorry for a rather short stream, but I hope, maybe you found something, and if only it is the Game Engine Black Book, which I can very much recommend if you're looking to do some retro game dev. Debug yourself quickly, indeed, and so I shall. Thank you everyone so much. I wish you a wonderful week. Thank you for dropping by and being so kind. And yeah, again, I'm sorry for the rather short stream. We were only getting started, but that's also my headache talking. All right, bye. Thank you. Hello there, ladies, gentlemen, and unicorns. Welcome to another Pixel Prophecy stream. And this week, I hope I'm a little bit better than last week. And congratulations, Frank, on winning quiz with a new set of questions again. And Lady Mistleaf coming in second, and Cursibu third with 100 questions correct. And Tutvari official also with 100% questions correct. That was just one, but still only answer what you know the answers to, apparently. Hello, everyone. How are you all doing? How have you been doing? And let's see, is there audio? Okay, there is sound, and I got levels, and there's even background music playing, which is good. Also, thank you everyone for sharing your watch streaks. I'm so glad that even some of you caught me last week, despite me having to cut short my stream, because I had the onset of a migraine in the afternoon, and for some reason I thought it might get better when I'm just doing the stream. And who would have thought it, looking at the glaring lights and everything. It got slightly worse, and then it got worse by a lot. So I had to cancel the stream, not even halfway through. So hopefully today we can carry on a little bit longer despite another stressful week. You know how it is with me with stressful weeks. Yeah, we had the builders in, and of course this is always in Austria. I don't know how it is in other countries, but it's always when the workers tell you they will arrive on the next day somewhere between 7:30 and 2 in the afternoon, and then actually they showed up at 6 in the evening. They were super exhausted already and super sloppy, and so long story short, they fixed some cracks in the walls, and actually they were meant to paint it over, but since we have here, as you can see in the background, certain colors on our walls, that of course they didn't have the colors to, and I didn't trust them to paint after all the other work that they did here. So it was for Connie and me also another busy Friday just painting, but I can show you the result because I had a big old crack in the wall that is facing, at least I'm facing the wall, but thanks to modern technology, let me see if I can get this to work. Haha, yes, we got picture in picture. It's me. Double vision. I got the old webcam, and with this webcam I can show you now how finally it looks, how it's supposed to look, disregarding the glare of the light. But this is our printer, and here we have finally, after 3 years, I finally got to this a bit of a home improvement that is getting the wall mounts for the guitars, and one of them in the center is already a little bit bending. So it never ends. It never ends. But as you can see, thankfully behind me now there's a little less clutter now. So it's good. And then on yesterday, I had a big reunion from college days. So we hadn't seen each other for 15 years, and it was loud, and but it was also super nice to catch up with people you haven't seen in over a decade. So and this might also be the reason why I'm a little bit sore in the throat today, because afterwards we went out and it was just lots of shouting and trying to understand people. So I think I've recovered. With Connie, I had a nice trip to the cafe today where there was lots of coffee and we had tea. So my sore throat should be all good by now, hopefully. So let's see. Lady Mistleaf missed last week's stream. You didn't miss a lot. Like I said, it was just an hour. Migraines are something I never dealt with, thank goodness. With me, I'm not even sure if it's a proper migraine, because there are some people who suffer from migraines. And I mean, I had a very severe bout of headache, and I had the onset of it. It was happening when you know it probably from some tensed up muscles. It radiated upwards from the base of my skull upwards through the entire day, and it didn't get better. So probably it was a migraine, but whatever it was, it wasn't fun. Kersey says, when you gotta get something done right, Pixel Prophecy is hard to beat. Well, with do-it-yourself and home improvement things, I wouldn't say I'm very talented, but because of all the experience that we had with certain workers, in the end, I mean, while I was waiting for them, like I said, they were meant to show up between 7:30 in the morning. You know me, this is not the usual time that I get up. So I had like 3 hours of sleep so that I could be there when they would arrive. And of course, they didn't for almost 12 hours. Yeah. And of course, in the meantime, this is when I started watching YouTube tutorials on how to fix those cracks yourself. And I was very close to just getting to the depot and getting all the necessary tools and just cursing while I was doing it. So yeah, essentially only trust yourself when it comes to dealing with workers. This is what I've realized. Frank says, I hope you didn't get any post-mortem takes with the cracks you might need extra shots for. Thankfully not, but the good thing is with the crack on the wall, as long as I'm not moving in front of it, it's relatively simple to just plaster it on in post. And even if I were moving in front of it, it's also not a big deal because, I mean, the wall, you've seen it, it's of a bright, friendly yellow or goldenrod, as some of you know, the color's name. I can just key it. So thank you for the concern, but I think I'm good. Let Me Slip says he can probably just edit the scene and add a little splash of color to cover it. Yeah, painting is another thing because, I mean, maybe I can find the picture of how it looked before when the builders were done before we did the paint work. And of course it is of a very certain kind of yellow. And the good thing is, I mean, it's possible to get the exact same color. So this is how it looked when the cracks were fixed. And yeah, then so for us it meant just and there was by the way, there was another crack in the wall. This white strip you can see here. This is also that was fixed. That is sitting on this side. So yeah, in some minor cracks, but the good thing is again, I had lots of panic attacks. I would say, when painting it. But overall, Connie did lots of paint work herself, and she wrote me a nice little sticky note of all the things that I should look out for. And be sure to tape everything off and switch off the electricity when you're painting over power outlets. And beware, paint is a little bit splashy, so you might want to cover yourself and all these things. And thankfully, it worked flawlessly. I don't even when I did the second pass, I didn't see any fringes or borders or anything where I could see the original paint underneath. So thankfully it turned out much better than I had ever anticipated. So I think now I'm a licensed painter. Well, without the license. That sounds unpolished. Exactly what the post-mortem takes. Of course, or over-polished. I mean, now the wall is over-polished. Frank says there are two ways of living with poorly finished home improvements. One is accepting that you didn't do better. The other way is to remind how much you paid someone for it every time you look at it. Indeed, and I'm at the position now where I look at it and think, well, at least it's the best that I could do. And it didn't cost me just a lot of nerves, but really it's literally nerve-wracking when you're painting something, or even when you with the drill, as I drilled the holes for the mounts for the guitars in the wall. Some people are natural home workers or do-it-yourself people, and I'm none of these. I had sweat was dripping down my face, not because it was such hard work, just because I was so super stressed out that I was making a mistake, and I don't know, the walls would kind of crumbling down, or I would just push through to the other room and just knock everything over. I'm already getting the shakes now just that I'm thinking about it. So all good. I'm fine. Oh, I suddenly realized why you ordered the playdate, says Frank. You mean because of the colors? Or the crank? It's almost exactly the right shade of yellow. Exactly. This was a really wonderful coincidence. So some people would say that I ordered the playdate after I saw which color it came in, and then I looked at what the hell this thing even was. But it was just a happy coincidence that it is exactly my wonderful yellow goldenrod the kind of color. I also like it for my notebooks, the paper notebooks, and it's surprisingly hard to come by. And I wanted some running shoes, and Nike doesn't have that color anymore. I have some old shoes which are dark gray, grid and yellow, just look perfectly. They don't sell them anymore. Now it's all these lime green things. Oh yeah, I'm getting old. I'm complaining already. And the cover almost matches your walls. I mean, yeah, that's a little bit of a stretch, but I mean here in the grading, it's when I tilt it slightly, then the hue is, I mean, that's actually for purple hue and the background is a dark blue. So it's, well, as a colorist, I would say improvable, but yeah, close enough. Lady Miss Leaf says, Goldenrod makes me think two things, the color and the third Gym City in gold, silver, crystal. Oh, are we talking about Pokemon? Oh, never thought about this. This is almost like product placement. I mean, I should be getting paid. I mean, I'm even wearing my Super Mario Odyssey shirt and not getting paid for it. But yeah, that's the thing with this channel. No, I'm so grateful that I do not need to get paid from anyone apart from your wonderful, hopefully voluntary contributions to your old pal Pixel Prophecy. So I'm very grateful for that. Yeah, by the way, I had, of course, since I'm doing a broadcast and in Austria, I'm based in Austria, and of course I need to somehow register that I'm a broadcaster, despite just being a very private or a rather minimalist broadcaster in a sense. Yeah, I don't have the audience of the bigger streamers or stations. Anyway, I needed to register in the registry, and I did. And they said, yeah, we need more details. How many subscribers do you have? How much money do you make? And so on and so forth. So I said, okay, they shall get what they ask for. And I sent them what was it, a 10-page long PDF with different kinds of graphs and numbers and tables and so on. So I just drowned them with information. And yeah, this week they called. At first I didn't realize who is calling me. What's this abbreviation? Yeah, and they informed me that hooray, my Twitch channel is too small. It doesn't need to be registered, but of course the YouTube channel does. But yeah, I didn't have to bother going through all my records and for each month going through it, and said, yeah, my revenue was €2.53. The next month it was €1.49. So of course now I'm too small for them to be considering me in any regulations. So please do not subscribe or follow this channel so I stay under the radar. Right, Kirsty says the wire on the mic stand is also blends into with a stream border. Oh yes, indeed it does. And I mean, this yellow cable, this was also a happy coincidence, because when I was setting up here the audio chain, I had the microphone relatively low so that I wouldn't clip when I talk loudly, and would have the compressor take care of everything, which of course everything was rather quiet then, and the compressor brought up the noise, and I thought this was due to the cable, so I got a different cable, and this yellow cable was advertised as the most noise free cancelling cable there is. And yeah, I thought, you know what, I like the color, I don't care about the properties. Well, I cared a little about the properties, but yeah, the funny thing is really this I always joke that I didn't know that my favorite color was yellow until I realized that I made everything yellow and dark gray or black or something. But yeah, in the end, this is also why I did the Pixel Prophecy logo overhaul last year, or was it already 1.5 years ago? Because I feel it's much more me when it's yellow. Apparently, I'm a very sunny person. Underground stream, says Cursibo. Indeed, yeah, we're in the underground now. Your streams do not need to be registered, and those graphs were detailed. You want a job. Is always when there are certain inquiries with federal bureaus or something, when they ask same thing with the tax office, I always give them way too much so that they have to sort through the data, and that's the same thing. That's usually my MO. If they request some information, I just give them too much information, so if they say, do you have any income statements for this year and this month? I say, okay, I got copies of everything. It's all printed out. Here you go. It's, I don't know, 72 pages. It's not 72 pages, but yeah. And then I'm good. They have everything they need. They have more than they need, and I have them off my back, essentially. You probably have to grow quite a bit before they can. That's the thing. It's 73. Right. Talking about numbers. I wanted to do a little sort of, I don't know, a lottery or something, because I thought to add into the quiz, where I thought wouldn't it be nice to do a number guessing game. And yeah, I don't know why I had this idea, and I just got carried away and then tried to implement it, because I thought this was a couple of nights ago when I was coming home from work, was rather exhausted, and thought, you know what, I will try to implement this as an exercise, and I'm programming it in one go and not doing any testing or anything. Afterwards, when I'm done, I just hit F5, or since it's running in the browser, and it should just work. So the thing is that today we still had a regular quiz. It's a clear indication that it, of course, did not work on the first try. Why would I assume that it would, especially after a long weekday? Anyway, so the idea is, for now, I just leave it out as it is. Again, it was just something to maybe break off the good old quiz with something that is a little bit less easier to guess as it is right now. So yeah, exactly. It was like a game. So I'm thinking of a number between so and so, and then the next round it would say, this character, or this not character, this user is the closest to it, and it's a little bit more or less than that, and this would have been the game. So it's like 2 rounds, and then they would say who's the closest, and yeah, it did not work. And I think it did not work brings us perfectly, it's a wonderful segue to what I want to continue showing you. Welcome to my cluttered desktop. Oh, I closed it. And that is today's topic, and we're doing some free Pascal programming not in DOS. We're clearly not in DOS, but for DOS, so to speak. So cluttered, says Lady Mist. Yeah, the funny thing also was with the reunion yesterday, we also had one of our old professors there, and he prepared a little presentation, and he was known back then for being the epitome of scatterbrained. And in his presentation, of course, his PowerPoint presentation crashed 3 times, and we saw his desktop, and it was worse than mine. He was running a Mac, and there were hundreds of little icons in the bottom bar, and I've never seen these tiny icons, because it was probably 50 or 60 or something, and so many tabs open, and of course, the PowerPoint presentation was 4.3 gigs in size, so no surprise that it crashed. You haven't seen cluttered, says Lady Mistleaf. Yeah, for my taste, it's a little bit too cluttered, because you're only seeing one screen. This is actually not really presentation friendly screen, so to speak, but the other screens are even more cluttered. And the good thing is I don't have to look at it, because there are all these stream windows, on top of it. So let's put this back, and it looks much better now. It's the digital equivalent of sweeping something under the rug is just move a window on top of it. Frank says, my game dev today has mostly consisted of watching my laptop play online chess while smiling. Isn't this the best kind of game dev? You spend so much time and work into programming or coming up with this algorithm and implementing it, and now you're at a point where you made some artificial intelligence, no, not that kind of AI, and just watch it play and see the fruits of your labor. Things just clicking. You said it's losing, but it's not crashing. And hey, I mean, what more can you ask for? Lady Miss Cliff says, I have less than 12 icons on my desktop because it's a new computer. 20 icons, I mean. Did you upgrade your computer? Because I'm looking to upgrade my aging notebook. 6 months ago, I thought, yeah, it's fine. Probably shouldn't upgrade. And then I had a project at work that involved lots of LLM upscaling of images, and it just kept overheating and dying on me. And now I'm not finding a replacement for it, because there are certain things that I'm super adamant about in my notebook, and finding the right combination of, I want this kind of keyboard, I need a keyboard with a num block, and I need a screen that's a true UHD, so nothing like 2550 by 11440 or something. I need really UHD, and the other thing is probably I need a P3 calibrated, and I don't care about weight, I don't care about size, I don't care about RGB lighting, and it's so hard finding something that fits all these things. And of course, one thing I've already given up on is I do not need an AI co-processor to speed up my Copilot Plus. Oh Jesus, I hate it. I just hate it so much. And it's in every notebook there. And everyone is selling you their cloud LLMs, AI anyway. So why do I need this to run local? Anyway, I'm getting off track again. Oh, it started winning, says Frank. It's winning a fair share. Congratulations then. And you put it up, of course. Wonderful. Lady Miss Liv said, I actually did purchase a new computer, and now I'm running both computers. One monitor on my new computer specifically for gaming, and 2 monitors on my old computer for game dev. So you're having like... are you having connected up 3 monitors, or is it 2 monitors and one you switch between old and new computer? That's another thing that is I'm trying not to do, to have like 2 computers underneath, because it means even one more thing to administrate, and I'm already way behind on cleaning this computer and my notebook, because with the notebook I've given up like 4 months ago, because I thought, yeah, probably when in October, November I will have a new notebook anyway, no need to clean up. And I mean, of course there are certain things that I like documents or invoices or something that I really need to get off there, but if I'm getting the new notebook, I probably will do a clean sweep of the existing notebook, and then we'll just maybe put on just Linux and OBS and have this as a portable streaming station or something. But nothing that I need to actively administrate anymore with all my software. Okay, it's 3 monitors. I ended up with a free monitor with my computer. Oh, it's nice. So get it as a package. Free because it came from the US and I had to pay shipping and hefty duties. Oh God, would have been cheaper to just buy one here locally myself. Oh yeah, that sucks. Lady Miss Liv says, bar not a fan of laptops. Desktops are where it is. The thing that I really like about notebooks is, especially the mobile workstations, as they're called, is I can sit in the cafe and do some productive work. I do enjoy sitting in the cafe with my Microsoft Surface, because it's just so super portable. The screen, I can paint on the screen. So for game dev, medium game dev, it's okay. I can run emulators on it. I can do DOS programming. So what we're seeing here, half of it was programmed in the cafe on my Surface. But what I cannot do is anything involving my videos and that sort of thing, like 3D animation and compositing and VFX and video editing. Boy, this really the programs nowadays really demand processing power. And the good thing is, when you're really sitting in the cafe and you can, I don't know, render something out, it really feels like I love this feeling that I'm on top of the world. Wherever I am, I got everything that I need with me. Oh, Frank has an update: 19 wins, 17 draws and 17 losses right now. Okay, I think that's a good ratio. One of the wins is against me, so it doesn't count, and the other one is against a human player who walked away halfway through, so that's also questionable. Okay, I mean, if you take very long for your turns and you just speculate on the other just losing patience and walking away, technically it's a win, right? Lady Miss Liv says, fair, understand it. I would rather stay in our gaming cave. Yeah, that's the other thing. If you never have to leave, I mean, I'm also a big fan of having a solid desktop, because I mean, I get 3 screens, and to quote or paraphrase Terry Pratchett here, when he was asked, Terry Pratchett, why do you have 8 or was it 6 screens, like 3 and on top of each other? And his question and his answer was, because I do not have room for 10. And it feels a little bit with me right now. No matter how many screens I have, I always wish for more. And again, this is when you have a decent workstation, especially for games. I mean, I'm playing mostly indies now, but whenever I play the occasionally one of the more triple of the A games, or quadruple A, or quintuple A, whatever they're, yeah. Anyway, it's kind of nice that it's possible, and I don't have to reduce the quality to medium or even low. No, I can crank everything up on maximum. I'm not playing it at full 4K because I'm worried that it's slightly choppy for the games. But yeah, and for that, really a solid desktop PC is, at least for me, it's where it's at. Trying to save money anyway. Very little cafe outings for me. Yeah, that bloody computer was expensive. That's the thing. I mean, if you buy a computer, really it has to work for at least 4 years, and if you can get 8 years out of it, it's a miracle. But it's very welcome, because I mean, nowadays just the graphics cards, the GPUs, they have so skyrocketed in prices, and it feels like you can have a solid computer, and for the same amount you can have a graphics card. And it's the same thing with my desktop PC, where the graphics card, I think, costs pretty much as the entire rest of the PC. So yeah, it's crazy. Oh dear. Frank says, one of the losses is against Balima, who, according to analysis later on, made no questionable moves at all. Oh, okay. The questionable moves. I'm not good with chess, but I mean, to me, all moves are questionable, especially when there's something like en passant going on. It's like, you can do that? What did you just do? 6 screens to emulate a Gundam cockpit, right? I mean, you never know what you can use them for. Oh, this would be nice. And Kirsty says, when you get 10 screens, you'll ask for a holodeck. Probably at some point, it's just better to say, yeah, I need just one screen that warps around, like the set of the Mandalorian. Lady Miss Liv says, I'm on 5 years on my old one and it's still working well. Right, so never throw away a running system. The only thing is, of course, when it starts smoking when you plug in the power, which I also had. En passant is very annoying indeed, says Frank. I don't know much about chess, so I just name drop some things that I know about chess. Queen's Gambit, there you go. Hashtag chessmaster. And Kirsty is watching Frank's bot in another tab. Oh, that's nice. I hope this is not a competition of who's more entertaining, because I fear I might lose against the chess bot, especially when it's entertaining to watch it. For playing, it's fine, but for programming, okay, so it's different. And Lady Miss Liv says, I lost my first piece to the easy computer. What is the first piece to the easy computer then? I wonder. Yeah, in the meantime, maybe I should make what we have here a little bit larger. And for those wondering, I think this was last time a question. I'm not sure how many people are here or weren't here last time. So just do a very quick summary. And the first one is, what is going on with the icon there in my VS Code? This looks different and not like VS Code. And just starting, yeah, this icon here, and this is VS Codium. It's an open source fork of VS Code, and to my understanding, it's pretty much exactly the same minus all the Microsoft things. So you don't need a Microsoft account to sync your settings. I mean, for me, this is sitting with the user settings in a Dropbox, and when I'm on the go with my notebook, and my Dropbox is synced, then I can open up right where I was with all the extensions and everything. It just works, which is wonderful because I've really grown attached to VS Code. And when it started doing pulling a Microsoft, I really was looking for an alternative. So VS Codium is so far great for me. And I lost a pawn. First piece to the easy computer. Now I get it. I thought you were building an easy computer and you lost the first piece. Now I get it. I lost a pawn playing against the lowest AI difficulty. With chess programs. I mean, with chess, I know the basic rules, but that's it. I don't know any opening games. When I play chess, and one round of chess for me is like it's over in 5 minutes because I'm not thinking. I'm just clicking and playing and seeing. It feels like more like some sort of random state machine where it's I'm just playing by ear. That's probably you shouldn't play chess by ear because it doesn't make any sounds and you will lose. But I'm having fun, and I used to lose against a chess program that had the setting on drunk, which instead of taking your pieces, it would stop one field, was it one tile in front of your piece instead of taking it. And even against that, sometimes I lost. Frank says, no, you sacrificed a pawn to get a positional advantage. That's how the pros describe that situation. It's all about framing. And Lady Miss Sleep says, was never good at chess and I haven't played in years. Yes, same for me. I think the last time I seriously played chess was 2002. I think I almost forgot. It's 8x8 tiles. What I've been playing was most of the time now was mech chess, which is Into the Breach. I think I've also played this on stream a couple of times back. Okay, so I'm talking about DOS game development. So I started doing Pascal because I thought I don't trust myself to get started with C or even C++ from Borland for DOS programming, but I want to have it one step beyond what is QBasic, despite it already there being good compilers now for QBasic and DOS. So they produce much better performing executable files than the old compilers would. But still, I thought I needed something in the middle, and then I remembered Turbo Pascal, and that I always wanted to look into Turbo Pascal, but when I was a kid, I did not understand any of it. I played around a little bit with Delphi or Delphi. I don't know how you say it in English. In German, you say Delphi. And all I did was for Windows, it was I'd make a themed or skinned media player. So essentially the function was just play, stop, and open file, but all the buttons, I don't know, would look like ice cubes with icons inside or something. So this is my only experience with Pascal until I think 1 or 2 weeks ago when I really started dabbling with it. And so finally, after 2 weeks, I started adding and experimenting and reading some of the good old black books on DOS development, because there are many weird peculiarities when it comes to display adapters and how VGA handles memory and certain arcane ways of doing speedups. I'm doing none of them. Well, maybe I'm doing one of those things that I thought that I somehow can pull off myself without going too much into the weeds of the actual hardware. And the cool thing is I got it working, and it's running on an emulated 386 computer sufficiently, and I can show you the quote-unquote game that I have made as a demo so far that is working with it. And yes, the other cool thing is I can work in VS Code and have it compile in DOSBox X and then run the executable file in DOSBox X. And this is essentially a DOS program running here that is compiled from what I wrote here. And I feel like this is so much more convenient than trying to do it in, I don't know, Borland Turbo Pascal IDE in DOS, because all your user, the keyboard shortcuts that you're used to don't work. And it's a hassle, so it's good that I can use VS Code for this. The chat says, same, I was kind of, says Frank, maybe not terrible back in school, but then that's 35 5 years ago. Kirsty says, you made your own chess-inspired game. That's close enough, right? Exactly. Thank you for remembering. For those who don't know, what was it called? The Memorandum, the Ludum Dare game, I think you're referring to, where it's also this 1-bit style essentially, and you're playing as a pawn, but it was rendered from the side, but the playing field was from the top. Anyway, so yeah, this was most or less chess inspired because artistic things. So yeah, what is this game? So yeah, here in the background, I was just looking at pixel art that I made that would lend itself to being and converted to EGA colors, and that I could use here in DOS, and that's not too distracting. So what we have here is misses and hits, and when you click not the ball, then you get a miss. And you would think, oh gee Phil, it's awfully simple, but at a certain point, after a couple of clicks, there's a random chance involved that one of the directions of the ball might have a certain speed set to it. So now it's just a horizontal and now just a vertical, and at some point, yeah, it should mix, and suddenly things get much harder to click and to get right. And it's weird because it's probably the simplest game that you could make, probably, that still counts as a game. And I think, as with many games, is as soon as you have a counter that counts hits or misses, you have a score. And I don't know how it is about you, but for myself, it's as soon as a score is involved, despite claiming that I'm not really interested in the score, but more of the game, into the game itself. Of course, you look at the score, and at some point you try to see, okay, can I beat my own high score, or what's the ratio? So essentially, again, it's a demo, because what I'm checking is, of course, is there a collision between the current mouse position and the current position of the ball? And oh yes, maybe I should emulate the CPU speed to a 386 33 megahertz. And you see it's much slower, but it's not terribly slow. So this makes it much easier to click the ball. But the thing is that I've shown in the last stream is because the ISA bus in the early DOS computers was just too slow to push enough pixels from memory to the graphics card in time for a new frame. So you would have something like, when you were lucky, 15 frames a second, or on slower computers, depending on which algorithm you used to just move the bytes over from one memory to the next. Sometimes it would even be like 1 or 2 frames per second. So already in this incarnation here of a very simple DOS game, I'm already using some speed up tricks also here for the mouse pointer. And the speed up is using dirty rectangles, which means essentially, the idea is with these kinds of DOS games is to try to transfer as little pixels as possible to the graphics memory and just reuse what you already have. And dirty rectangles is the implementation where when I'm changing the position of say, let's hear the ball, it says, hey, these pixels, this rectangle in which I was in has changed. So of course, when the ball is moving here on top of this part of the image, nothing else of the image needs to be redrawn or should be redrawn, because it's just, it doesn't change anything, but still it's transfer of pixels. So essentially it's this implemented where I'm keeping track of a number of rectangles that gets drawn and redrawn. Same thing here for the mouse pointer, which also always looks where it was in the last frame and where it was in the current frame, and then just notifies the drawing engine, so to speak, that it says, hey, please redraw the background where I was on the last frame. And when I'm not moving, then there is no necessity for updating it. So this is, at its heart, is the thing. But of course, there is, as always, since DOS gaming is, or DOS game programming is so close to the metal, even when you use something like Turbo Pascal or Pascal, there are certain things that you wouldn't think are necessary or take time. But first, let's see what I have here in the chat. Terrible chess game. Lady Miss Liv says, White is victorious. Computer had first blood, but I ended up winning. Congratulations. Sorry, I'm done now. All good. And Lady Misleaf asks, Frank, do you actually see all the games in real time? And Kirsty says, looks like a video game to me. Thankfully, thank you very much. How much performance boost for this game doing dirty rectangles? Well, I can show you, probably, maybe not for this game, but I have some tests here. But the performance boost is, I would say, substantial. I mean, what we can do is, instead of doing drawing dirty rectangles, which I'm doing here. For example, here I have this function that I call patch VGA buffer with background. So it patches only the dirty rectangles. When I say fill the VGA buffer, which means to transfer the entire background buffer every frame to the foreground. And let me switch over the CPU from, once it started, from what we're having right now to, where is it? 386 DX with 33 megahertz. So when I'm moving the mouse pointer, you can see already the frame rate is kind of terrible. And as soon as the ball starts moving, yeah, this is kind of terrible, right? I've on the socials, I think 1 week before, I made a comparison of my different algorithms of doing loops in Pascal, then doing pointers. So instead of instructing or doing the writing to memory via, I don't know, arrays, actually I'm looking at the memory and reading the pixels from there and so on. So yeah, it's already quite a difference, and it feels rather sluggish. And also the audio changes, and when I'm clicking, sometimes it doesn't quite register because so much time is spent here just redrawing things. So, and yeah, just patching the things that changed again. When we have the direct comparison, it's noticeable. CPU speed 386. So the mouse pointer again is much more responsive, and here that's the same speed the ball is being animated with than we had before. So yeah, I would say that's an improvement. Of course, there are much more things that you could do. I mean, I'm, for example, using a double buffered image display. So instead of writing directly into the video memory, I'm writing to a buffer, and only when the video card has finished drawing a picture, only then I transfer the new bytes, the changed bytes from the buffer into the video card memory. And so this means when I'm doing dirty rectangles, first things are updated in the buffer, and then the same things that I redrew in the buffer get updated to or pushed to the actual graphics card, to the hardware. And so this is why I'm having things like patch screen from VGA buffer and patch buffer with background. So essentially, I mean, I can quickly walk you through the program here, but first let's see what's going on in chat. Lady Misliv says, so you used to make games with GameMaker, and I stuck to JavaScript and wrote my own engine, and it slowed me down. Now I'm learning Godot, and you're switching to Pascal. Frank says, bah. And Frank can see everyone playing the games. This is nice. Actually, that one ended now, the game that I was playing. And Kirsty says, big difference, good job. Thank you. Again, it's... I'm so glad that the old nerds documented their stuff and speed up tricks, because back then all you had maybe was some publications or one, two, three different books that you could look at when it comes to DOS programming, and maybe know someone else who was a better programmer than you could ask. But apart from that, you were stuck with what you had. And so some games like the first Duke Nukem, the EGA platformer, so not Duke Nukem 3D, for DOS also had some peculiarities, like a tile-based collision detection system instead of just keeping track of rectangles where things are happening. Because, I mean, how would you know? So you just try to get crafty. And I was just lucky that everyone had documented their stuff, and the dirty rectangles is apparently a very well-known way of doing things. So yeah, it was easy. Once you know how to do it, it's relatively easy then, instead of coming up with yourself the entire thing. So I'm glad that I could just build upon this. You can silently judge me. This is also a thing that I thought once would be super nice. When you have, I don't know, a big multiplayer game or a game that's played online against computer opponents, and you as the developer can pose as an AI for some random player where you can say, you know what, I want to take over this game and play as the AI. And of course, the player will never know that they at some point are playing against a human opponent and think, oh my god, how is this done? This is incredible. It's even mocking me, for example. F-chess bot, not F-chess. Okay, that name was taken. Oh, F-chess is already taken. What does the F stand for? Frank or functional chess? So yeah, with Pascal, just quick overview how it works. So this is my main function essentially. Can you see this, or should I make it a little bit larger? Maybe one tick larger. So you give it a name, and in this case this is a compiler mode. So Delphi, it says, so the default values in functions work, but then no binary notation, which I don't need, because of course you can always if you know how to, you can always transform binary ways of printing numbers into hexadecimal, for example. Then it uses certain, this is essentially like header files where you can say, yeah, I use the CRT. In this case, I said I use it to read the line, which is essentially just when you hit enter or something. System utilities to convert integer to a string, or math just for the minimum function. And then we have here pixel prophecy units, and those are pixel globals, VGA1, game images, font, mouse, keyboard, and VGM playback. You probably notice there is no VGM playback, because this is something that has been holding me up quite a while. And Frank said, yeah, it might stand for Frank. Okay, all good. I mean, in the end, you can always come up with something else and then just deny that it's, for example, what was this, where something was clearly named after the programmer or something, which often happens. And as also often happens, the programmer said, no, of course I'm not that vain. It is an acronym for, and then something very obviously tortured words to make something up that it just fits the acronym. We all know how it goes. So essentially, these are the header files. And the other thing with Pascal is that it's a little bit annoying is any variables that you need to define, and also their data type. For example, you can see here that we have text is of ttext, or music is of pvg music, or debug font is of pfont. So you can, of course, define your own types, which in this case, you see those types aren't defined because they are defined here in these packages. So units, as it is in Pascal. So, and then I have here one procedure that is only used in this main function here, that is spawn sprite, where you just say, please where to spawn the sprite. It's where you can just give it a random range. This is when you click the ball and then it appears somewhere else, and you can give it a sprite. Again, sprite is nothing that is implemented. Again, I'm running my own thing here. So when it says sprite and it's of tsprite, that comes from the pixel game images unit, and this is the game images unit. So essentially, when you say you want a sprite or move a sprite, first you get a sprite from an image. In this case, it's a PCX file. Then I'm using pixel PCX. Where do we have it? Here. And then I'm parsing the PCX file into a data buffer. And then I'm passing this and giving it back and say, hey, you wanted that sprite. Here is the data where every byte stands for an index into the current loaded palette in VGA. And then, of course, I'm having here sprite as my own type. And for example, if you want to know what it looks like, so here, sprite, tsprite, I think this is a common way of doing things in Pascal, is if it's a type, you prefix it with a big T, and if it's a pointer, you do it with a P. So essentially, I just say a sprite is a record. It's a bit like a struct, you could say, where I say, is it valid? Has it changed? Width, height is small integer, speed, And this is important when doing dirty rectangles. Where was it last? And what's its size in bytes? And of course, I'm even having here 128 characters for an error message. For example, when something with the loading goes wrong, it passes it as a string as the error function. And the data itself is of pointer sprite data. And this is the actual pointer that we returned from the PCX loading function that says, okay, those are in memory, those are the bytes where this sprite is composed of. And so here the sprite data again is just an array of bytes, and it's 0 to 0, which means at this point we don't know how large it is. So and one other thing here is so the pointer to sprite data is the array to T sprite data. So essentially this means, hey, give me the pointer to this object here. I think it's, if you do it like this, it's on the heap. And if you want it somewhere else, you have to allocate it yourself. And probably you can already tell that's a little bit different than from what GameMaker is doing, where in GameMaker, yeah, I just say, hey, GameMaker, give me a new buffer of that size or make it dynamic, and I don't have to care about how large it is. And here it's really, I have to pass pointers and offsets to pointers and do some pointer arithmetics and so on. So yeah, it's for me, it's a different way of programming things. But the cool thing is so far it's working. So this is when I say I want a sprite, I have my own way, my own functions of rolling sprites. And again, the sprite is just some image data and a position data. And when I say, hey, please, with this sprite, or check if there is a point collision between the current mouse pointer coordinates and this sprite, then of course it looks at, okay, where the sprite is currently on the screen, how wide it is, how tall it is, and then does the calculation and returns true or false, for example. Lady Miscliff says, it reminds me of an interview with the governor. Me when I'm talking English, you mean? Right, so when I say here spawn sprite, again, the sprite is my own type. And then I say, yeah, give me a random position for the sprite when random position is true. And again, here, when I defining here a function, essentially I'm defining a function, and those are my values, my parameters. And what you cannot do in vanilla Turbo Pascal is where I say default value. So in this case, random position is true, so I can just omit this when I'm calling the function. I do not need this parameter. But for this to work, I need to set the compiler to mode Delphi, that this actually works. Otherwise I get an error message. So again, this is just to make a sprite. It's just, again, a function, and here actually the actual main functions begins. So what do? We clear the screen and set the quit variable to false, because as soon as this is true, the game will quit. Then we're still here in the text mode. Then we write a line of loading assets. And again, this is another thing where I said, there are things in there you probably wouldn't assume that you need those. And again, this helped me up a little bit. So because there is no font support. I mean, you can, if you know how, you can say, please give me the current BIOS font for DOS. But this here is a pixel font that, of course, again, I have to roll myself. So and how does this go? Well, I have here a load font from file. This is in, where do we have it? Pixel font. So this is my function to load a font. How does this work with a font? Well, first, when I call load font from file, I give it a PCX file. In our case, that's just a grid of characters. And then this file gets split up, of course, for each glyph, for each individual text character. It gets data structure and also some reserved memory, where it writes the bitmap data, essentially just for every pixel a byte. It uncompresses it essentially into memory. And also it's indexed by ASCII character value. So for example, what was the first ASCII, or the big A, the uppercase A, I think it's 67 or something. So when I'm parsing a string, I just look at the string, at the individual ASCII values in this string, and these ASCII values minus 32, because before those are just control characters, is the actual index into the array where I can find the data, or in my case, the pointer to the data of the glyph. And then, of course, it like with a sprite, it looks, it gives it to the video memory and tells it, okay, I need to change this byte in the buffer and mark this rectangle here now as dirty, so we need to redraw it and so on and so forth. So you can see it's very close to the metal, and the interesting thing is I thought this would drive me crazy, but on the other hand it feels somewhat liberating, because when I'm doing things with GameMaker or Unity or Godot or pretty much anything Windows, it feels like I have no idea how many layers of abstraction are there. When I say in Godot, hey, please make this a 3D scene, I'm not 1 second concerned with where in memory do the textures sit, where is the geometry buffer, is there a depth buffer, how is forward rendering on, how does this communicate with the graphics card. This is all hidden from me as a user, and I don't understand it. And of course, when there are certain bugs, like I don't have in the current experiment with Godot, I don't have any shadows anymore, and I don't understand why. Probably never will. And so in doing it like this, where it's essentially I've personally cut up all the characters in this font myself, so that I can put it in memory. And of course, this makes it much easier to understand how everything is connected and where things are. And when you run out of memory, you think, okay, probably because I'm like 3 times allocating X and Y or something. And the other cool thing is, of course, you can do things, or you can come up with certain things that probably no one else but you will need or will ever think is neat. And I want to show just quickly what this is. So for example, here, let's have a look at the images of this test. And where is the font, just so that I can show you how the font actually looks like. And so this is my font type Atlas. So again, it starts here in the upper left corner, and this is ASCII value 32. This is a space. This is ASCII value 33, 34, and so on. So I'm just starting here because the ASCII values before that are just control characters, which I don't need. So, and the font that I'm actually reading looks like this. So instead of it being just a black and white image, it has a certain background color, and this fuchsia color you probably might have seen before. And in my engine, this is designated as, hey, please make this transparent. When this is of this color, make it transparent. And the other thing that I can say now in my font is, hey, everything that is white, you know what? This is a wildcard byte, which means when I say, hey, please draw me the font in yellow, then everything that is white gets replaced now with yellow, but everything else, like the transparent color, or in this case, the shadows, they stay the same, which again is kind of neat. For example, if you want to make an adventure like the LucasArts adventures, and of course, Guybrush has a different colored font than everyone else to designate speakers, and you have a little bit of shadow so that it's easier to read against the background. And again, when I run my game here, you can see that this is exactly what I'm doing here with hits and misses. And this red O here, this is for trying to debug audio playback, which is not working right now. Only the PC speaker is supported. But essentially, this is how I'm doing it. I mean, you don't see the shadow now here because, of course, the background image is all black here. But of course, I could change the background image from GB to, what was it, Beans, PCX. And then we have a different background image, and there you can see here that this font has the shadow. I just changed here the background image because, yeah, it was a little bit busy and hard to sometimes hard to find where the mouse pointer is because it's blue against blue. But again, since I'm running here my own engine, so to speak. I like how transparent it is to me now at this point, because essentially I personally know every byte and where it comes from and where it goes. So that's essentially it. So here, mouse pointer again is just a sprite from an image, and the music is right now not supported. So when I say init mouse and init keyboard, I have here my units for mouse. So for example, here my mouse just reads the mouse status. how do I know where to read the mouse status from? Well, there are certain interrupt values that you can call, or for example, or that interrupt values that fire. For example, when I say when I want to init the mouse, I'm sending an interrupt with the registers of AX reset. Again, this is apparently the interrupt is at value hexadecimal 33, and these values for interrupt X for reset is 0, for show cursor is 1. So this is also nice, I feel, with DOS. So you just set a certain byte somewhere in a very known or very defined port or part of the memory, and something else in the system reads this byte or sometimes even bit and does something because of it. And of course it communicates back. For example, the BIOS, the system, communicates with interrupts, so you need to handle those interrupts, and essentially this is how it works. So in my case, when I say please where is then the current mouse status, then I just say here, okay, my registers are get status, so I'm writing the value of 3 into the interrupt register, and whatever I get in return, this will be the current status that I received. And of course I can say here, for example, in my case, I'm keeping track of, is the mouse button currently pressed? Is it the first frame the mouse button is pressed, or is it being held down, or has the mouse button just been released? Again, it's not built in. All that is built in is, hey, these are the X and Y coordinates of the mouse pointer at this current frame or whenever this is being pulled, and here's a bit mask of all the buttons that are currently held down. But again, if something is just clicked or held or released, you have to do this yourself. It's so low level, but it's kind of endearing how you have to figure this out. And right, Lady Miss Leaf says, and you just now described why I love JavaScript so much. I was building everything myself. Indeed. I mean, JavaScript is not that close to the hardware, but right, if you want to make something to make games, essentially you have to have some sort of equivalent of, okay, this is an asset, or this is an entity, and it is at these coordinates right now. It's displaying this image, and if it's getting clicked, it should know that it's getting clicked or something. I know what you mean. Yeah, I also tried something with JavaScript where I tried myself to re-implement poor man's game maker in JavaScript. Lady Misleaf continues, it's not an engine either. When I used Phaser, my breaking point was trying to figure out why half the collider was not working, but I never wrote that collider, so I couldn't figure it out why. Exactly, that's the thing. And when you start programming and then people tell you, you know what, you don't even need to understand all of this, just use this package there and this framework and then call this function and it's all good. And of course, it's all good if you follow to the point what the friendly person in the YouTube video is doing, and as soon as you stray or start to experiment and things happen and you have no idea why they happen, and when you want to debug them yourself, suddenly you have this whole jungle of different dependencies, and I always try to avoid this as much as possible, because for example, when I just need a very simple function like a clamping function, I don't need a 3 megabyte sized mathematical algorithms function, because all I need is like 2 lines of code essentially, and I can write these myself. So of course, if something is more involved, like matrix multiplications, well, probably then it's a good idea to use a library, unless you really want to roll everything yourself. But again, for me, it always feels best when at least I know all the code that I've written. Oh yes, a disclaimer. Some of the code that is in there has been helped with LLMs. In my case, this was ChatGPT and Gemini. And sometimes they would, when they were printing me out something, I mean, I only need, for example, a snippet, or where I say, hey, please, what's the difference between writing this in C# and Pascal? Because if it's written like this in C#, how would it look like in Pascal? And that kind of thing. Or hey, how do I initialize an OPL driver? Please comment. And sometimes it would trip itself up, but I never copied straight what the LLM gave me. But with every line, I looked it over and tried to understand what is happening there and really typed it off from the response that I got. Because, I mean, it's easy. It's very tempting to just paste and copy because you want to get something working and running. And when it doesn't, then you're back at square one again, because you have to try to reason what it was thinking and it wasn't thinking. It's a statistical tool, however advanced. So there is no thinking involved of whoever wrote this code. So essentially, you have to do the thinking. And I try myself to, again, force me to not just copy and paste, to really type it off, to not fall into this entire trap. Because as soon as you start to get lazy, and then you suddenly completely rely upon this. And I don't want this to happen. Right, what else have I missed? It's not an engine either, yeah, when I used Phaser. And yes, having done it yourself can make things much easier, even if you use someone else's framework, says Frank. Exactly, and I learned this the hard way. And Lady Miss Cliff says, it's what I loved about JavaScript. It had a baseline I wanted. Let me display something on screen. Let me figure out the rest. But everything else was all on me. It was long, but liberating in some way. Constraints were all of my own doing. Right, I think the best thing to JavaScript was the option to say, hey, here is a canvas. Here are the bytes to the canvas, knock yourself out, and also you don't need to implement your own text rendering function. We got some of these, or drawing a line or something. By the way, drawing a line or filling out something, that actually is possible with Pascal. There is a certain unit, I think draw graph, or what's it called, where you can do this. But really, I wanted to try this myself, to just really have, for VJA, I just have here, this is in memory, those are bytes, and every byte refers to the palette index of that pixel at this position on screen, and everything else I wanted to do myself. And yeah, the PCX decoding again was a little bit of a headache, because PCX is run length encoded, and I had to get wrap my head around this a little bit until I got it to work, and then I could build upon it and then say, okay, you know what, now I know how to load images. Then I can load sprite images. Then I can try to see how I can do transparency. And the next was doing text atlas, so that I can render sprites, not sprites. I can render text. I can render strings. So, and for the keyboard, it's a bit with the mouse, where all I have here are some constants, where the key for escape is 27 or 75. And you see here, I'm mixing now the decimal and the hexadecimals, which probably is not the best. And also I have here the pound sign and the dollar sign, which means why is this happening? Yeah, and if you feel somewhat getting better with documentation, I wrote it up, because when you look at this code, it doesn't make sense. Why is this now in hexadecimal? And here it says, this makes it a character which the case expects. Case, you probably know the case keyword from switch statements. Pascal has something similar, but it's not called switch, it's called case. But again, you cannot switch data types, and this is why I'm casting it to different data types. So this makes it a data type integer, and the hash makes it a data type character. And that's what's happening here. Right, what else is going on in the chat? Lady Miss Cliff says, I gotta go wake up, Harvey. Have a good day. And you too, and have a wonderful week. And thank you for sharing. Frank says, bye. And have you implemented the line drawing algorithm yet that I forgot the name of, but might think to start with a B? And Kirsty knows the Bresenham classic line drawing algorithm. No, I have not, because so far I do not have the need to draw lines. But from my cursory look at it, it's not as simple, because the thing with line drawing is always how to handle subpixels. Do you want to completely skip them, but then you have certain holes in there? Sometimes you have double, and yeah, that's exactly the thing. So I have not looked into this algorithm yet, but again, it's so nice that this is common knowledge by now. When I was doing my quick basic experimentations in the 90s, I didn't have any books on it. I mean, the only basic book that I had was basic calculations like how many French fries did you eat? 15. How long was each French fry? 3 centimeters. Congratulations, you ate a French fry that was 45 centimeters long. These kinds of things. So this is not what you want to read when you want to make games. So again, I didn't know any about these algorithms, and nowadays it's common knowledge, and it's so much easier. And thank you, Frank, for sharing this. Let's have a look at the Brazenham line drawing algorithm. And yes, I think I've been on this page before. This looks very, very familiar, because I mean, do you want to draw this part here? Because the line, technically the line hits this pixel, but then again you would have like 2 pixels here, the same thing here. So how do you where is the cutoff between, okay, this line is still inside this pixel and not? And again, yeah, it's a whole bunch of Greek letters, but the good thing is here there is some code that is relatively okay. It looks easy to implement. And again, it's a Wikipedia. Thank you. All technical documentation. Thank you. Everything is there. This makes it so much easier. Kersey says, after that you can learn to draw triangle polygons and import 3D model. Oh dear, please, not yet. I'm not doing my Alone in the Dark yet. But I mean, trigonometry, right? But I probably would have 3D models that are a little bit simpler. But I mean, that's the other thing that I really came to enjoy, is parsing file formats, like with the PCX format. Because when you are just a user, or you have a library that imports something, like with GameMaker, where I say, hey, this is a PNG file, make this a sprite, and it says, sure on, governor, and it does it. And here, when I'm reading a PCX file, really I had to look at the PCX documentation and know, okay, so the first is the byte of the manufacturer. Okay, this is always 0A. The next is the version byte, but there are different kinds of versions. So 0 means EGA, 2 means modifiable EGA, 3 means no part, and so on and so forth. And again, here you have an Xmin and Ymin, and this is a word of low byte, high byte, and so on. So literally, you're looking almost at bits, and in some case, you are looking at bits. And here, the EGA palette, and again, just how a file is structured. And again, it feels a bit like a puzzle. So the one thing is, so the puzzle is essentially, this is the rules. Those are the rules of this file type, in this case PCX, because PCX again is run length encoded. And so first I'm loading the image, and then I'm checking if the manufacturer is 0A, if the encoding is 01, and if the bits per pixels are 8. Only then I'm even trying to parse it. Otherwise I just say it's unsupported, because I'm not writing an image program. I just want I mean, I'm making all the graphics myself, so I just wanted to tell me, okay, hey, you forgot to change the bit depth in this image, and that's all. And here, of course, is the decoding of the the run length encoding and how long it is, and what happens if there is a repeated pixel and so on. And you also already see here we are dereferencing pointers and writing bytes into an array buffer and so on. And again, for me, it feels this is the puzzle, because if you figure out or exactly how the specification works, how to implement it, and then the magic is you open an image with this defined format, you save it in a program that was written 30 years ago, and if you did everything correctly, bam, it shows up on your screen exactly how it should be. And even if it doesn't show up how it should be, you can look at it and figure out what is going wrong. Good old off by 1 errors when the image is all slanted is, of course, yeah, just one stride length with a one-off error. Right. Frank says, if you like wikis, I'm also going to leave a link to chessprogramming.org. Oh dear. Yeah, the thing is, with chess, again, I know too little about chess, and to me it feels a little bit not constrained, the other word, too open, just too big for my puny brain to handle. But what I found myself is I think I have some links in my code anyway, is where old file formats like the VGM, the video game music format is explained. Because, spoiler, this is what I actually wanted to do or try to get running the past week, and just kept hitting my head against it because I was trying too much too early. That was music playback. But you know what, before I get into this, let me just quickly finish how this simple program as it stands right now works. So we've read the mouse, we've initialized the mouse, we initialized the keyboard. I'm initializing the VGA. What does it mean to initialize the VGA? And in my case, it means here also gets the BIOS font. You know what, this is wrong. It does not get the BIOS font because I could never get it to work. So I'm just setting the VGA mode. Essentially, this means in DOS you have the text mode and different kind of graphics modes, and this sets this graphics mode. So what does this do? Well, it's an assembler program that has just like 3 lines of assembler. And essentially this says, okay, whatever is here, this 0, move it into the high byte of the A accumulator, and $13, move this into the low byte of the accumulator, and then call interrupt 10. And once this is called, or 10 hex, I think that's what it stands for. And once this is called, whatever happens, it just reads this value that is in the accumulator right now, and then sets certain things in the graphics card that sets it to the VGA mode. And the same thing here with the text mode. Again, I didn't have to figure this out on my own. I just found, hey, this is how you set it to VGA, to graphics mode, and I just could copy and paste it because this is already a solved problem. So what happens next here? I fill the VGA buffer with the background, and the background image. What is our background image? The background image is a background from image in the image directory plus beans or GB for the Game Boy. And again, this background image is like Sprite. I implemented it myself. And so I thought it might be useful to have a distinction between a background image and a sprite image. Essentially, it's just bytes. But the sprite image, of course, does things like, hey, have I moved since the last frame? Or do I have a transparent color? When I'm plotting myself against the background, pixels that are transparent should be ignored. For the background, I'm doing certain assumptions. For example, a background does not have any transparencies, so I can save me this calculation. A background always has the same size, the bytes of the entire screen. So it's not scrolling or anything, it's not smaller than the screen, it always in memory has the exact same size as the screen. And this makes the calculations just so much quicker. And this is when I say, hey, fill the VGA buffer with the background and give it a background image. Again, this is essentially just copies whatever is in the buffer for the background. It just copies it one-to-one into the image file and doesn't image in the image video memory, and doesn't try to find, okay, where is the position on screen and what is the index of this byte in the screen memory and so on. So I realized that this probably was a little bit faster. Well, then of course I have another function that just says fill VGA buffer, and then I can just say that it fills it with a certain color, and the color again is just a constant that I defined. So essentially, instead of trying writing different bytes that represent different colors, it just fills it up with one byte value and the entire buffer. And so we have here some font debugging. So the font debugging, you know, if I enable it now, will print out the font that was loaded. Apparently not, because right after I'm drawing over it. But essentially it just prints out the entire font, every character just one after the other, and when it hits the end of the line, just so that I know that the cutting up of the image looks correct. What else have I missed? Kersey says, let me drop Isola songs, Isolangs, the esoteric programming languages. Oh dear, is there already one of the programming languages that I like there? Isolang, esoteric programming languages wiki. Oh dear, this looks like a rabbit hole. A non-deterministic language. Holy crap. And there's also the joke language list. So 2 is not a joke language, it's just non-determined. Oh dear. Yeah. Oh dear. Yeah, this looks like some fun reading. Thank you. And also thank you for redeeming Unicorn. Frank says, one interesting experience I had with chess is that I started without reading up on anything to see how far I could get from what I learned over the years by osmosis. It was a little bit here with myself. Only when I realized that probably I'm on the wrong track with certain things, and then I looked things up. But also, again, this is why I said, hey, just give me the bytes to the screen and I will manipulate the bytes and try to figure it out myself. And again, this is, for example, how I came up with the grand idea to, you know what, just assume the background is a fixed array size, and this makes things so much easier. And then I've read where people told me exactly this, and then I've also learned, you know what, maybe I even want to have some sort of tile image support, where instead of storing the entire image as it is, just storing a tile set and constructing the background out of these tiles. And again, this is something for future fill. Oh, poor future fill. But for now, I'm just happy with what I have. So yeah, I'm filling the buffer here with the background. And this is again a bit like with GameMaker, randomize, which means there is a new random seed every time the game runs. And then I'm doing the spawn sprite from somewhere. So somewhere on the screen, it should spawn the sprite with a speed of 0 vertically and the speed of 0 horizontally, or horizontally and vertically. So we have 0 hits and 0 misses. And here I say make dirty. And this essentially just says, hey, the entire screen has been, please redraw the entire screen. Essentially, it instructs, when I scroll down here to my drawing calls, essentially I just say, hey, fill the screen from the VGA buffer. So whatever is there, just fill the entire screen with what's currently in the memory, no matter how long this will take us. And here the actual loop starts where it says repeat, and it repeats until quit is true, and quit is true when a certain button on the keyboard, in this case escape, has been pressed. So what is happening here? Well, first I read the keyboard status. Again, I'm just looking at what a certain byte in a certain position currently, which values it has. And with some bit shifting here and there, I can figure out, okay, which button is currently pressed and so on and so forth. And since, again, I'm rolling my own mouse unit here, when I say hit mouse status, I'm also keeping track of, hey, has this been pressed? Has this been released? Is this button currently held? So again, now that I have it written, I just have it abstracted away from myself essentially, and just can say here, okay, if keyboard status is escape, so when the keyboard key escape is currently being held, then quit is true, so we're ending this. When I'm hitting F1, then stop the music, play the music, or pause the music. It's not working right now. I had here the mouse before this. Well, then once keyboard input is done, let's look at the input for the mouse. Again, same thing with the mouse, just hey, what is the current mouse status? And get mouse status just looks at this register in memory, pieces together what it is, and wraps it into nice, instead of having to check like bit number 3 from the left or from the right, instead I just say, hey, has the right mouse button currently is being held down. So, and if and only if the mouse status has changed, because this is, after all, this is DOS, so you want to be super lazy in a sense, only do things if they are really necessary. So only if the mouse status has changed, well, only then, of course, let's look, where is the mouse pointer, where has it been, has anything pressed right now. So the status also not includes just the position on the screen, but also if any buttons have changed. And only then we're actually looking at what has changed and trying to piece it together. And here we have if point collision of mouse X and Y with the ball sprite, then, well, we increase the hits, we spawn the sprite somewhere else, we kill any sounds that are currently playing and playing a new note of 440 Hertz and setting the sound timer to 3. And when the sound timer is 3, with every frame it gets decreased by 1, and if the sound timer is 0, then it kills all sounds. So what we're playing here is, so we hit the ball, so it plays this note. If there is no point collision, well, then we play the buzzer sound, so to speak. And again, it's a little bit shorter than for what we have, and we increase the misses counter. And I mean, it's really straightforward. It's a bit like with Game Maker, so certain things apparently never change. So I'm doing here some mouse position debugging. Essentially, I had the problem, this was super peculiar. So the mouse position, as you can see here, or let's put it a different way. So I'm here in DOS mode 13, hexadecimal 13, which means we have 320 pixels across and 200 pixels vertically. So the problem that I had, I was always checking, okay, is the mouse pointer where I'm currently at, and when I'm clicking it, I'm checking it, is it at the same coordinates in the rectangle of the sprite. And the problem that I had was it always said, no, it's not. And I figured out from just playing around with it, before I had here my debugging view of the mouse position, I realized that only here at halfway between the actual sprite position and where I am right now, only at the half point when I clicked, I had a collision. And it turns out that the mouse pointer, or the mouse register, so again, just have a look here at the coordinates when I move my mouse, and when I move my mouse all the way over, here it now says correctly 320 as the maximum position, and down here 200, so 320 by 200. But what the mouse actually is much finer than the current display mode. So I thought 1 pixel is just 1 pixel, but essentially instead of having 320 pixels, the mouse driver reports 640 pixels. And of course 640 is double. And of course when I'm checking here the mouse, so the numbers down here below, those are the coordinates of the top left corner of the ball here. So when I'm over it here, then it's exactly this position. So just so that I could figure out, okay, is the position of the ball wrong or the mouse wrong? So yeah, essentially the mouse is horizontally, I had to divide by 2, and vertically it was fine. But figuring this out, because I thought, since you're doing so much low-level stuff, of course it's your fault. You did something wrong. It can't be the driver reporting something incorrect. And as soon as I had my my font system implemented, that I could print strings while I'm running in this mode, only then it was super apparent what actually was happening, because I moved my mouse over and said, this is impossible, it can't be 640. That's the thing. Right, so what else have I missed? Frank says, then after that I got slightly annoyed and I hadn't thought of alpha beta pruning by myself. Again, I have no idea with chess and whole decision trees and everything. So alpha beta pruning sounds like either gardening or some advanced programming. And then, says Frank, I read up that Claude Shannon also hadn't thought of it, and I felt a lot better. Yeah, even if good old Claude Shannon of the Shannon's sample theorem, this is what I probably axiom something that I've heard somewhere in school back then. But even if someone with a big name hasn't thought of it, that's good. The same thing I always say, Einstein probably has thought up of the theory of relativity, but I don't think that Einstein ever programmed a microwave oven's clock. So I think, I'm not saying that I'm smarter than Einstein, I'm just saying he has probably his shortcomings. Kersey says, it seems obvious once you hear about it. And a 3D factor or third factor says, making terminal game not in terminal is such a lost opportunity. Pascal and Turbo Pascal had their own IDE that ran directly in DOS. Indeed, they had, and I tried it with them and didn't like it, and spent a lot of time to get this development system running, that I could do this in Windows, because there I have copy, paste, I have syntax highlighting, I can move blocks around with Control X and Control C, and it's so much more comfortable of programming things. I mean, it's like pixel artists who say, you know what? you're only doing it right when you use programs like Deluxe Paint. And I mean, I get it. It's for the retro appeal and the novelty factor of it. But at some point, I think, okay, I'm used to so much better tools now, so probably I want to use those tools. I mean, it's in the end, it's always a personal a personal thing. But for me, I realized, okay, as fun as it is to program in DOS for DOS, I feel like, yeah, there's a reason that even in the 80s, they programmed, I don't know, Maniac Mansion on big machines and just had a cross compiler and sent just the bits over to the good old Commodore 64 to test the game on the actual hardware. So I understood that now. Kirsty says, always adjust for the mouse transform. Yeah, again, that's something I've never heard before, and I ran straight into this issue. And again, it cost me way too much sleep because, of course, you don't go to bed when you think you're this close to solving it. This close. 3D Factor says, so the collision detection is a box. If it's a ball, circle collision detection is cheaper by just checking if distance from cursor to center of ball is lower than the ball radius. Yeah, the thing is, I'm not sure if it's even going to stay a ball. And for now, of course, yeah, you're absolutely right. It's cheaper. For now, I'm just having the upper left corner as my origin point. Probably I will even at some point come up with a different anchor point. For example, when you're making something like a platformer, of course, it's much easier when your origin is at the center feed point of your character. But yeah, of course, it's cheaper. Right now, I'm just trying to get something to work before I'm thinking too much about optimizations. But then again, I already did the dirty rectangle thing just to have it draw at a certain frame rate that is not just abysmal. Could try NVIM, not DOS, but still terminal. Yeah. I think at heart I'm more of a GUI guy. I've told this before. When I was at the University of Technology back then, when I was studying English at the time, but I was curious about how the programmers would do it. And I was there in the introduction course to programming with C++. And I was there with my wonderfully colorful, vivid Windows XP background, you know, the green planes, the blue sky, and all the big plastic-looking buttons. And everyone was using Emacs or something weird and was running Linux. And I thought, don't they know how to use a mouse? That's peculiar. So yeah, I was the odd one out. So right, so here is music playback that is not working right now. So when I have here this make dirty or mark dirty, this is just for the string that displays either this greater than character when something is playing, this O when it's stopped, or this pipe character when it's on pause. Again, yeah, this I tried to chew off too much that I could implement, and now I'm starting with a test program just to get the OPL working. So finally, after we have been checking our input, so first here in my loop, I got the keyboard status and checked if something happened there. I got the mouse status, see if it changed, something changed there, and then we're looking at the logic. And the logic is just a ball update. So if the ball is less than 0, well, then we just have it bounce off on either edge of the screen. And if it's bouncing off the edge of the screen, well, then we say, yeah, it's not bouncing anymore. Kill any sound that's currently playing and play here for 1 frame this beep sound. Why is it 2 when I'm saying play it for 1 frame? That is because I'm decreasing here the sound timer right after I set it here. So this is why when I always have to set it +1. And the sound timer, again, that's just a PC speaker, and it's if you set it a certain frequency, it just keeps beeping until you say, hey, no sound anymore. And that's this thing. So if the sound timer is less or equal than 0, then you just say, yeah, just stop the sound that's playing. And then you update the sprite. And again, the sprite here is one of my game images functions. And update sprite just says, where do we have it? Put pixel, mark dirty. Update sprite, yeah, we just give it, if it has a certain horizontal or vertical speed, we just add it to the current X and Y positions. We tell it, hey, the sprite has changed. And so if the sprite X is the same as last and the sprite Y is last, only then we say, okay, you know what, the sprite has not changed. Otherwise we say, yeah, the sprite has changed. unless of course maybe the speed is 0 or the in this case in either direction is 0. Again, right now I'm not checking it whether it is 0. So again, I'm running some unnecessary calculations here. So I'm adding +0 in this direction, plus y in this direction, and then I'm checking should we even add. So yeah, I know this could be optimized somewhat, but I mean that's also the fun of DOS programming. There are so many things where you can come back and optimize, and at a certain point I think you probably then are at assembler level when you want to optimize the heck out of things. Right, so what have I missed in the chat? Could try anyway, right? I think there should be ABC music notation definitions for Pascal. Or are you doing MIDI polyphonic music? Yeah, that's the thing. Right now, this is just a PC speaker. So where I wanted to have these bleep sounds, and I always wanted to have some proper OPL music playback so that you can just have the ad-lib, take full advantage of the ad-lib sound card. But yeah, I will get into this, just quickly finishing here my main loop. So after we update the sprite, essentially again it's just the bouncing of the sprite, and then we wait for the retrace. So as soon as we know that the graphics the graphics memory is not accessed anymore because currently a frame is being redrawn, once this has been finished, then we can update whatever is going on. So in my case, I'm just putting the string hits and misses there. Again, not optimized because the word hits and misses is not really changing from frame to frame. And right now I'm drawing this every frame, also the number of hits and misses. So again, this is another thing that could be optimized. So only when it changed, we need to redraw it. Then we draw the sprites. Since this is again here my draw sprite function, this is here what happens, what's happening. And there it looks, hey, has the sprite actually changed? Is the sprite actually on the screen? And only then we put the actual pixels into the buffer. And again, also the buffer checks, hey, is this pixel on the screen? I mean, if a sprite is maybe, it's possible that it's halfway cut off on either end of the screen, and the put pixel function actually checks, okay, if it's out of not in the screen anymore, well then we don't need to draw it, move on to the next. And also this updates here the dirty rectangle. So this is why I'm just saying, hey, draw the sprite. The sprite knows where it was the last frame, the sprite knows where it is the next frame, and only if it changed then it will actually draw. And finally, here it happens, transfer to video memory. So all that happens right now, we have been drawing into the screen buffer. So again, this is double buffered and it's not actually in the video memory yet for the video controller to draw. So here, again, I say patch screen from VGA buffer. And let's have a look at VGA, or let's move it here. Or do I have it here in VGA? Patch screen from VGA buffer, yes. So what happens here is it just looks at the dirty rectangles, and for every dirty rectangle it just transfers only these things here where into the memory of the graphics card. The memory is starting at $A000 and just grows from there. And of course then we have an offset for the rectangle. Again, this is being calculated here. And also we can just say, instead of using here the VGA buffer, it's a bit faster if you say, hey, just for example, if it's on a solid background, I can just say, hey, patch the VGA buffer with a color. So for example, when we say here patch VGA buffer with color, and we say like color, let's go dark red. So as soon as I'm moving my mouse pointer, probably it will, or nothing has happened anymore. Why is nothing happened anymore? Let's see if I changed something else. Oh, I think I know why. Because first I need to draw what is actually there. And so I'm patching the VGA buffer from color. No. Okay, I'm not understanding my code anymore. So we're patching the screen from the VGA buffer. Oh, right, and I'm writing now into the buffer with color and not on the screen. So essentially, I'm not updating the screen. All I was doing was writing into the buffer, not to the screen, and that was the thing. So what's happening here is we only transfer the rectangles that have changed to the screen, and after that we patch the VGA buffer with the background. So essentially, at this point, we're drawing all the sprites that have moved, and afterwards we have it on screen. We can say, okay, you know what, all the sprites, just patch it up again, because the sprites will be redrawn with the next frame. And of course, here we reset the dirty rectangles. And when we quit, we just say no sound, we close the OPL, we free the memory of the sprite. I don't think this is necessary, at least this is what I've read, that when you terminate a Pascal program, you do not need to free the memory, but yeah, I'm not quite sure. So it's probably safer to free the memory myself, and then I switch over to text mode again. Right, Kirsty says some sort of profiling is key if you want to find slow spots. Yeah, this I've realized is the hard part with DOS programming, is really the debugging, because if something crashes with Pascal, it's at least a little bit better than when you have to open up a hardware monitor and look essentially just at the bytes in memory where something is, which I try to avoid right now, because most of the bugs that I had were just I'm trying to access a memory that is not that doesn't exist, because again, I'm off by one, good old overshooting by one. Or the other thing is wrong data type, or I'm reading a word, but instead I should read a byte from something, in these kinds of things. But of course, profiling essentially means, in my case, just switching everything off, or having like 2 or 3 algorithms, and then just timing it, just running it, recording, and switching it off, exchanging or changing the algorithm for the other algorithm that I think is faster or slower, and then just timing it again. At least for me, this is the only way I found a workable way of profiling. And the other thing, of course, is this is all running in an emulator. So again, the performance is a little bit flaky and changing at times. So yeah, and again, what I'm trying to do now is making music that is possible that I can play back in DOS. So for the Adlib card, this would be OPL music. OPL, yeah, that's a Yamaha chip. So I think it's just operator mode 2 and operator something mode level 3. Essentially, this is frequency modulation synthesis. And there are different formats. I think id Software had their own format, which was essentially just the control commands that you just push to the sound card. Again, it's a little bit like with the graphics card, where the graphics card just reads a certain buffer and you can access it. For example, in the VGA mode, you can just, okay, if you write a byte to this register, it will be a color index of the current palette or something. So essentially, as a programmer, I don't have to transfer anything or transfer to memory. I just know, okay, this is the nook that I need to push in my bytes, and it will come out in the right place if everything was set correctly. And OPL works a little bit similarly, where the sound card or the OPL interface has I think hundreds of different registers, and depending on what byte you write at what register, certain things in the hardware get set. For example, you can say the attack of the node is set by the next byte I push into this register, for example, which means you can change how a node sounds. So and I thought, you know what, this is probably the best idea, is instead of trying to play each node or make a node program here where I just again use notation and say, yeah, this is a minor C and it's of half a measure long. Instead, I want to use a different program to make the music that is more comfortable than just punching in numbers. So I looked at different file formats, and of course, what program do I want to make my music with? This was my first question for pipeline's sake, and I thought, starting from that, I can figure out myself, probably, maybe, hopefully, what the best course of action will be to read these files. So I mean, it makes sense, as we had here with the Doom's music format from id. IMF, I think this just stands for id music format, which has a certain header and a certain way of identifying, okay, here starts the data stream. So it's relatively simple, very close to the hardware, but the only thing is I probably would have to write myself a converter from a different music format so that I just get IMF, because at least the programs I've looked at, some don't exist anymore. Of course, virus scanners go all haywire when you try to run some of these old hobbyist stuff. And of course, you have to make it a certain kind of MIDI file beforehand. So I thought, okay, you know what, if I have to write my own converter for this, I mean, I can use a different format and write a converter for this as part of my audio driver. And essentially this is what I did. So, or I'm trying to do more or less. So what software do I want to make my music with? And for me, this probably will be Furnace. So for those who don't know, Furnace is a multi-chip system agnostic, almost as it's called, tracker. So you can make Game Boy music with it, you can make Super Nintendo music with it. Essentially, if we look here at managed chips, if I open here the chip manager, I can say, you know what, I want a new chip here in my song. And those are all the chips that are supported. I mean, down to the Super Nintendo, the NES, whatever the Dave is, or the bifurcator, SID3. So this is really dozens and dozens of chips. And you also have here Yamaha OPN2 or OPL2 with drums. So essentially it's the OPL2 that I want to support. It's the YM3812. So essentially this I would choose. And usually I start here with my NES chip music. So let's kill this. And now everything here is set up in this OPL mode. So you can see here I can already make some music, and it probably sounds basic and horrible, but essentially that's the gist of how to make music. Again, in Windows it's super convenient. Of course, if you are somewhat against using the mouse, I've heard it multiple times that the most convenient tracker there is the Adlib Tracker 2. And again, I've looked a little bit into it. I found it less than intuitive, but if you probably get the hang of it, this has, I think this is the gold standard for FM or Adlib tracking there is. Again, this is essentially running in an emulator in Windows right now, and again, there is no mouse support, at least none that I know of. And again, it's a little bit cumbersome to get into, so this is again why I'm using Furnace, just because I know it already. So what can I export my Furnace music as? And I can export it as a WAV file, which is not very useful when I want to target DOS. For example, I can export it as a DMF, that's a DFLMask module format. You might ask, what the frick is DFLMask? And DFLMask is this wonderful thing. Let's skip this. And it's a tracker. It's a tracker like Furnace, but this is more tailored towards anything with the FM synthesis at the base. So we're talking about the Sega Genesis, OPL2, OPL3, and so on. And with Furnace, you have different formats. So I thought, okay, probably then I should use it. I could convert it to DFLMask, and from DFLMask get a file format out that is probably better suited to Adlib, which is not the case. Spoiler alert. The other thing here is a command stream, which exports a text or binary file which contains a dump of the internal command stream. So I thought, you know what, we're getting a little bit closer, but it says technical development use only. So yeah, this might be a little bit problematic. And of course, then text exports the song to a text file, which is, again, then I probably would need to parse again the note data and try to figure out, okay, if it says G2, what frequency is this, and so on. So probably more hassle than anything else. But what is VGM? VGM is essentially, this comes, as I understand it, more from a homebrew scene or from a reverse engineering scene, from people who wanted to save the music when, for example, when you're running on an emulator, do you think, you know what, this music track is kind of nice that I'm running here, I don't know, Aladdin on the Sega Genesis emulator, and you want to capture this music, but not just as a WAV file, but the actual commands that are being sent from the game to the audio hardware. And I think this is how VGM originated, because this is a music format that does pretty much what I just said. It records all the commands that are being sent from the software to the hardware, and there are different formats, and it turns out this is exactly what I need and what I want. And I already made here a demo sound, and then just picked apart the file format. And as I said before, my passion is parsing file formats. And so this is what my pxvgm.old, as it is right now here, is doing or should be doing. Let's switch it here to pass, that we get some syntax highlighting. But essentially, it is reading this VGM file, it's parsing it, and then writing all the commands to a buffer. And when I say, hey, please play me whatever is in this file, it knows how fast it is, what chips are involved, and then essentially just parses the command stream. And the good thing here is, again, it says here vgmrips.net, and this was so helpful, the entire VGM specification. So you know exactly where in the header you have to look at. For in my case, where do we have it? I mean, you can see here all the different synthesizers or chipsets that are supported. So this is just a header file, and I'm interested in the YM3812. So when something here at byte 50, when here 32 bits, so 4 bytes are set here, then I know, okay, this is actually a valid file. And the next thing here is it lists just the different versions, where the data offset is, where it tells, okay, this is where the data starts, this is where the actual command data ends, and so forth. So once we're through this, then we get here the commands. And the good thing about this is I don't have to understand any of these commands. All I need to understand is, hey, if in the VGM file I get here like this 52 hexadecimal, well then in or 51, as it, or what was it, in our case 52 or 51. Anyway, so this is OPL2. This is why you can write 2 ports. But essentially all you need to say is, hey, okay, if there is byte 51, the next byte is the register, and the byte thereafter is the value to this register. I don't have to understand what the register actually is or what the value is. All I need to know when I'm implementing this is, okay, whenever I get command 51, write this there, essentially. And this is exactly what I'm doing here. So when I'm 5A, 5E, and 5F, this is when I also wanted to have OPL support for OPL3, which for now I'm good with 1. So yeah, exactly. This is, again, here the YM3812 chip. And here is, okay, if the byte we read from the buffer is $5A, then we read the next byte as parameter 1, and the byte thereafter as command. So the first one is the register in the audio card, and next is the value. Then of course there is $61, which means, hey, we just played a note, so we have to wait for a certain amount of samples until we play the next note. And again, you just read out, this is a word value, so it's not just 1 byte. This is 1 byte, but some others are 2 bytes. So there are different lengths that you write in terms of integer lengths. So and there are certain shorthands, like $62 waits 1/60th of a second, and $33 waits a 50th of a second, because it's much shorter. Again, 50th and 60th, this stems from, again, we are running this for example, in an emulator and want to record this. So once every frame, depending if you're on PAL or NTSC, this happens very often where it just says, okay, wait 3 frames until the next node, wait 20 frames until the next node. And instead of having always, okay, write X number of samples, it's a shorthand in the file. And of course, if there is $66, this means it's the end of the sound file. So, and as you can see here, this is called vgm.old.pass because it's not working. Because again, I said I tried too much too early, where I'm allocating memory and I'm burning just cycles. Because, yeah, when you write something to the sound card, you have, as we've seen, you have to write it a certain value to a certain register. But between those 2 writes, you have to wait a certain amount of time because, of course, the hardware, the sound card needs time to process what you just gave it. For example, if you say, hey, this is the port and this is the data, and the audio card needs to say, hold your horses, I need to set the port first correctly, and we have to wait until the port is there and all the lanes are correct for the next byte that comes in as the data. So this is why I have here burn cycles. And yeah, my music handler, that's the next thing that is not yet implemented is so you're playing, your game is running, but how can you play then music? Because as I've said, you have to wait after a certain note to play the next one. So how do you keep track how long this takes? And in DOS, you can do this via interrupts. So essentially, you can have a call back to yourself at certain intervals where you can also set timer value where you say like 60 times a second or 70 times a second, no matter what is currently going on in the code or on the display. Hey, interrupt my code, run this type or this function here. And in my case, this means it looks at what is currently being played, what node is this still, are we still on delay? Because if so, then do nothing and return from this interrupt, or else fetch the next node and push this to the sound card. Again, this is not working right now because, again, I tried to have everything file reading and pushing registers in one go, and it did not work. Sorry for the long monologue. I will catch up with the chat now. Right. Okay. So Frank said freeing memory is often not essential at the end, but still it's good practice to do. Again, yeah, this is why I have just to be in case. And even to remind myself when I have, hey, free the background, free the sprites. It's just, yeah, good to look at everything that you have allocated and see, okay, did I forget something? Because just when you go through it step by step, what's happening, even if you do not see the memory leak yet, there might be one. Case in point is the mouse pointer. It's at some point I was reading the mouse sprite every frame for some reason. Memory leak. Cursor says, can hand roll some basic time measurements of different parts of the frame if you need. You can. Okay, that's good. That's good because I might I might need to come back to this. Frank says, for example, if you do debugging tools can then tell you how much you allocated and how much you freed, and if you cleaned it up, and that should be 0, and if not, you probably have a memory. Exactly. Yeah. In the end, it's just simple arithmetic. It's just adding to the pile and then taking things off the pile. And of course, in the end, if you're not at 0, something happened and you were over allocating. And the worst, it's okay to over allocate, but if you don't free everything that you over allocate as well, yeah. Right. Frank also said, if your graphics hardware allows for beam racing, that thing with palette change is taking effect right when the CRT is currently being drawn. There's cool profiling trick you can do, switching palette every time some part of your per frame logic is done, and then you just look at where the colors change on screen to have a good estimate of how long each part took. Okay, that's kind of neat. I would have never guessed that. It makes total sense because I love visual tools, and it helps me so much more than when it says, this frame took 6,469 cycles longer than the last one. I think, thank you. But if I can see in the frame and see, okay, I still got half a frame left, or it already took 1/4 of the next frame before it changed. That's a good idea. Thank you. Cursor says music has tricked Phil into essentially learning an assembly language. Yeah, that's the thing, right? It feels like a bit like emulation. because I don't need to understand what's happening here. I just have it. I just push the right register, the right value to the right register, and the thing itself takes care of it. I just need to have this wrapper around it, and writing an interpreter for it. Exactly. Life is tricky. Yeah. So what is working right now is this OPL test, and you can see here this amount of bytes. And what is this? Yeah, this is my test data. So I had lots and lots and lots of problems with my VGM unit, because even for the life of me I could not get out a single beep of the sound card. And in the end I did things, I started overthinking things, and then looked at documentation for the Sound Blaster from 1991, where it said, okay, to set up a Sound Blaster you have to do the following things and clear these registers. And I think I have some of this here anyway. Init VGM, I think, if it's still there. Oh no, that's just to do. Or okay, this was not the old one. Yeah, this is the one where I was just trying to throw things at the wall and hoping for something that would work and stick. Yeah, I have here all my ports for the interrupt, the OPL port for the Sound Blaster, and for compatibility, and the data registers for the different channels, and so on. So yeah, this again, and looking here, as always, it's always super helpful to yourself if you nick something from somewhere, and to really figure out where it came from, because then you can look at it in context and figure out if something that you just more or less copy pasted, why it's not working, because of course it's in a different context perhaps, or something that you had. So, and also here in my first implementation, I just read the file, the VGM file, and created my own data structure where I had little packets of commands, and then would work these commands. Here in my newer, more naive implementation, as it is here, I'm not turning this into command objects or command instances or command structs, essentially. I just say, hey, this is a big old array of bytes, and just, you know what, read one byte after the other. This doesn't have to be, this made this complicated, because again, I was over engineering things. And this is why I have here like end, like multiple nested things, which is never good. Yeah, here when I say play note again, this was just copied from Gemini, where I said, yeah, just write me in Pascal how I play a note, just for testing, and even that did not work. Good thing is it worked in my more naive implementation. So essentially what is happening here is, let's run it and hear it. I mute the music, and maybe you've heard a certain note, and this already says OPL adlib detected. And when I first heard this note, I was just so happy, because for 3 days, like I said, I couldn't get a beep out of it, and suddenly I had this one short note, and then I knew it worked. And when I hit enter, it's playing the OPL data. Much too fast, but this is the actual data, the actual song that I that I tested. This is just one pattern. You probably have recognized it. I didn't take long to compose this, but it worked. And what does not work, at least in this implementation, is how the speed of it, because I'm using a function that is called delay, or in this case, I'm not using delay anymore. I think, that's just for detecting OPL, because it's so dependent on the hardware. And the worst part is it's also dependent on the software, in this case the emulator, how long a delay between notes takes. So I mean, it was recorded, or the intention is 1/60th of a second is the delay. So every time it checks, hey, is there a new note to play? It just advances this counter, or assumes that it's by 1/16th of a second. So from 1000 milliseconds divided by 16, so 60, we get 16. And where do I have my delay? What I'm saying here, play test data. So my delay is here is now 14. If I switch it over to 16, for example, and you just heard it, and if I do this twice in a row, it will play at different speeds. And the thing is, I don't know why. And Frank says it does sound familiar. All right, the automated unicorn, you cannot feed it a burger just yet. So I've heard everywhere use delay with Pascal for this. What I had before was this good old for loop. Of course, this is very dependent on the actual hardware it's running. And let's comment this out and use the for loop. And I'm running this now. I'm emulating a 386 computer, and it's exactly, for some reason it's super slow, and I have no idea why this is happening. The only good thing is that okay, let's switch the CPU and emulate, I don't know, a Pentium. Yeah, this was much faster. And I don't know why this is happening, because again, everyone said use a delay, and even the Pascal documentation says, yeah, that the delay time, actually this is milliseconds, but it can vary greatly between different runs, and I think this is not really helpful. So the actual way to do this is to use a programmable interrupt timer, and again, this is what I tried here, and I couldn't even figure out whether the interrupt was being set up correctly, because I do not have an understanding of how to debug it. Because it's easier to have an interrupt when you're in text mode, where it can just say, yeah, when the interrupt is running, change something, print a character on screen. But of course, printing a character on screen takes time, and maybe this also is with the interrupt not working, or not working. Is interfering with the interrupt, so to speak. So again, the only way to debug interrupts that I figure out is just to try and yeah, just trial and error essentially. And my problem was I wasn't even sure that the audio was being loaded correctly at this point, or whether I was writing to the right registers in the sound card, or whether the sound card would actually receive the bytes that I sent it, because as I've said before, you have to wait for a certain delay between sending it bytes and so on. So yeah, this just posed a huge problem, and this is why this file is so big, because again, I was just writing different approaches of things, and then yeah, just stepped back and started from scratch over. So this play test data, since this is blocking everything else that's playing, so again, you cannot play a game while this is running, because it will only update the music. And since you do not know how long each update or how long each frame takes, this means also that the music is somewhat might get asynchronous. So what my next steps in, because again, here the music is hard-coded, so just that I have something that I can listen to while I'm testing. The next thing is actually to reading a file from disk to buffer, and then playing this buffer. The next thing, yeah, play this buffer, then playing the buffer but not from an interrupt, and then playing the test data here from an interrupt, and then playing back the buffer from an interrupt, and then I can know that something is wrong maybe with the interrupt. So long story short, this has been my last 2 weeks on and off just trying to get music working. And I'm not talking even about sound effects, it's just music. Right, Frank says one thing you can do is calibrate your loop on startup so you know what to count to. Right, that's the next thing. Yeah, one other thing is, of course, as I've said here, this 5A here means I'm sending just some data to a register, and at some point most of it is here 62, which means hey, just wait for this frame. But so the further I scroll down, here suddenly there is a lot of 62 commands, because at this point the audio hardware is being set up. So if I scroll up here, there is 162 in here. Everything else is different commands. So this means when I first start this song, all these commands here are setting up the different instruments that I'm using to play this song, which of course takes time, because I'm not running one command, but it's like dozens and dozens of them. So 5A means okay, to port 1 write value 20. To port 80, write value 0F. Again, this is just setting up the different oscillators so that once this is done, we can play the actual notes. And here after 62, it's just, hey, play this note in this channel, play that note, and then just wait until you play the next note. So again, this means probably at some point that as optimization would be, hey, when I load a song, I already set up the sound driver or already push all the instrument data, the how the oscillators should behave to the sound card before I'm even playing it, because when I start to play it, then all the data should be there. Otherwise, for example, when I stop a music soundtrack that's currently playing and start it over. Currently my implementation is, hey, you know what, just start here from the top. Just read here the first byte and implement this. Despite, of course, the audio hardware already having all these instruments, all the oscillators are already being set up correctly, which means probably the first couple of notes are a bit choppy. Again, my God, DOS programming, it's you think completely differently, where it's like, I've never would have thought that with audio, I would say, okay, how long does it take for the audio hardware to set up playing my MP3? This might have been a problem if you're writing a online game where you stream all the music data, where you feel like, okay, maybe I need to buffer a little bit. But again, this is something for future, Phil. But it just occurred to me that, again, this might be a little bit too advanced for me. Anyway. And Commander Stitch is here. Welcome, Commander. We're just looking at bytes right now. So this is already super nerdy, what we're here for. And YNOC says, I'd love to know what started you looking into doing all of this. Good question. And so a couple of streams back, I was doing a DOS game with this framework, the ACK, the Adventure Creation Kit. And I think, Frank, you said that it was under the hood, it was programmed with Pascal, because the Adventure Creation Kit is essentially, you can make a game like the first Wasteland with it, or the early Ultima games, something along those lines, where it's just tile-based movement. And I thought, you know what, it's fun, but probably with DOS gaming, I want to get a little bit more understanding of the hardware side of things. And the other thing is, I think there is going to be DOScember again this year. And I think there is a game jam for DOScember happening in November. So you have some time in November to make a DOS game for DOScember and hope that people play your game in DOScember. And so I thought it might be good to familiarize myself with DOS. And since I'm not doing Ludum Dare this time, because I'm not in town for Ludum Dare, I might do a little documentation maybe, and also attempt to do a different game jam, and this would be the DOS game jam. And again, for this, I want to just have a basic framework that I completely coded myself, set up, that just does some simple graphics, simple audio, simple text rendering. And from that, I just branch out and see what is possible. But you know me, I'm a very visual person, and I like things polished. So this is why I'm looking into, okay, how can I do graphics with this? How can I do sound with it before I'm actually looking more into, I don't know, collisions? Because again, right now I only have point collisions. But yeah, that's the short answer. And nice bites, says Commander Stitch. And Frank says, oh, you mentioned MP3. Now do gapless MP3. I don't think this is possible. Is gapless MP3 even possible? I think these people who have sent people onto the moon think, you know what, this is not possible. And the others, yeah, gapless playback. I think as long as if you don't have sole control over the audio buffer and the file format even. I mean, gapless MP3 might be possible if you do some clever rendering or decompressing first and have everything in a buffer or something. I'm not too well versed with MP3, but I've heard that I know that it's a hassle. Right, so instead of using here this hard-coded data, let's see what we can use from here my early implementation when I'm reading something. Because again, I'm having here certain bytes. In this case here, this again is a packed record of one, so every byte is a boundary essentially. And I'm having the pointer so this is a song in the VJM format. So I'm reading it in, and it has a pointer to where the data actually is. and the record itself has a certain size, so I know, okay, how many samples are there and at what position we currently are and what the current delay counter is. Because if we, as we've seen before here, 62 means a delay of 1 frame at 60 frames per second or whatever the song was recorded at. And by the way, this also, this recording rate of the song actually is also something that is in the header of this VGM file that we can look at and look into. So I think here I'm parsing the VGM file anyway. Where is it? Do I have it here or somewhere else? I think I have it somewhere else. So when I'm saying here load OPL, I go here, and yeah, you can see when I'm loading things, I have here my header. So I'm not checking much of these things like the version sub or the version main or the actual sample count or any loop offsets just now. All I'm checking for is, okay, where is the end of the file? Where is the GD3 offset? So GD3 is like with MP3, you have this ID3 tag, which is a tag where it just have some strings where it lists the artist, the name of the track, the album, and so on. And VGM music tracks also can have this, but it's usually at the end of the file. And again, a VGM file is set up that you have a header that is by default usually of 256 bytes. Sometimes it can be a bit shorter when there is nothing there that is important. It can also be longer. Then is the command stream, and after the command stream is this GD3 or not. So again, if it's 0, then we can ignore it, because then we know, okay, all the command stream, the file ends after the last command has been sent. And again, I'm writing everything that I've learned as a comment in the same line. So also, by the way, what's happening here? So what does this mean here? This, for example, end of file offset or the data offset. So the data offset is where is the actual command stream starting and where does the header end, essentially, because I said it can be shorter or longer than 256 bytes. So for example, just to give you an example how it looks here with Pascal. So what I'm doing here is plong int, which means, okay, whatever this pointer is pointing at, whatever is there, I'm interpreting it as a long integer. So it means I'm reading 32 bits, 32 bits. Yeah, it's a 32-bit, 4 bytes that I'm reading. So, and what I'm looking at is the address of the header. So this is in memory where the header is at offset 34. So, and I'm dereferencing the value that is there, and I'm adding 34 to it. What is going on here? You probably have seen this here again, where I'm reading something at a certain offset and then adding the same value to it. The reason for this is, again, it took me a while to figure this out, is that all the offsets here are stored relative to where they are in the header. So if something is at position 15 and it says, hey, in 15 bytes from here starts the data. So to make this reading from the top of the file, well, of course, it starts at byte 30 and not at 15, because 15 is a relative value of wherever you're looking at. So again, this number here says, hey, 15 bytes later, or 14, or in this, well, it's hexadecimal, 20 bytes later from here, the GD3 starts. Or in this case, from the other end of the file. Never mind. So again, to make this not relative, but objective, starting from the first byte in the index, I add something to this. Again, it's super simple. Took me way too long to understand this. Frank said the massive thing about gapless MP3 is that MP3 uses fixed length chunks. So by nature of an MP3 file has to be an exact multiple of that length. And Frank also says, I forget what the chunks are called or what the length is, but importantly, even though MP3 originates as the audio part of a video file, it's not related to 25 FPS or 29 FPS. It's its own annoying number. And we have this so often where things, numbers do not line up because they come from different parts of data or of electrical engineering, like for televisions, right? The frequency of the individual scan lines is also something crazy, because at some point it started from the current, and then and when you use it with computers, and something is base 60 and something else is base 50, and it's super hard and annoying to get it to actually at a point where it's reasonably enough. This is also why we have in video still we have drop frame and non-drop frame, where something is perfectly 30 frames per second, or it's 29.9779 something, because it's 1001 divided by something else, and that sort of thing. Frank says, if you take a random video file and look at the individual tracks, quite often audio and video are not the same length. Exactly. Yeah, that's the thing. Because as you said, they have different chunks, and videos usually, not in all cases, but usually are divided by frames, video frames, and with audio you have chunks. Some uncompressed audio has samples, and of course you have like 48,000 samples per one second. And so again, this when you try to divide the frame, divided by 25, then you have the number of samples per frame. Yeah, it's complicated. It's complicated. So this is what I'm doing here. I'm just reading. When I'm reading a file to load an OPL file, well, first I allocate the memory for music and music data. What is music and music data? It's even a global variable here. Let's investigate. So where are my variables here? Okay, so music is a pointer to the data type VG music. What is then VG music? Glad that you ask. So pointer to VG music is the pointer of this record on the heap. And this is a record of a short string of an error message and a file name. Again, this is just used for debugging, whether it's valid, if it was loaded, if it's currently playing, or if it's paused, if it's looping. And here, this is another important thing. This is the pointer to the actual VG Music data without the header. And the data itself is again a record of, this is what we had before, the pointer, where it starts, how long it is, where we currently at in the music file, and for how long we have to wait until we read the next commands. And essentially this is it. So when I'm loading here a new music file, load OPL, I'm allocating here just some bytes for the header, and I'm allocating here the music and whatever, I'm dereferencing the pointer here. So essentially music array is music data or something in other programming languages. So, and for this, again, I'm just making room for it. And then I'm setting the default value, so it's not loaded, it's not valued, the current file name. Then I'm loading the file. These again are things here for the compiler, where I say, okay, if it works, then we reset, and if it did not work, this is the input-output result is 0. Then we say, okay, there was an error opening the file. We return the file or the object without pointers to data, because there is no data. We just say, hey, this is the error, it's not valid, and we exit. So exit music means we just exit, and this is the data structure that we pass, that we return from the function. But if it's valued, we write the file name to screen. So this is when it says loading assets, so that it shows up there. Then we reset the file. So essentially it means, yeah, just wherever the pointer might be on the file, just go to the first byte of the file, reset the error, and then it says block read, and we read the first 256 bytes into the variable header, or not the variable, but yeah, the array that we have here. So 255 indexes, well, 256 indexes into the byte, into the array of bytes. And again, this is the header. And essentially, this is just a template that we put on top, where we say, okay, at this point, where is our end of file offset is at this point in the header. So whatever value is there plus 4 is in the array that we get back in the buffer, the actual position of this. Frank says, which caused me to do video editing at some point. Oh yes, before that, he says, back in the day I've seen some Linux video editors produce out of sync files by getting this wrong from assembling clips. Also on Windows, there are tools, I recall tools where they say, yeah, just combine or merge these clips. And this was in the early 2000s. And of course, they were never sync. And the more clips you merged, the more out of sync they drifted. Yeah, exactly. Frank also says, which caused me to do video editing at some point using uncompressed UV video, so YUV, and raw PCM audio, all using the DD tool. Oh, have I heard of this before? If you're semi-familiar with DD, this should make you recoil in horror. I mean, it rings a tiny bell faintly in my memory, and this ring of the bell doesn't feel good. I think I've heard this before, but I mean, even uncompressing just to get this to work, I feel you. Yeah, video, audio, data combinations. My God, yeah. At work, we often have this when people say, yeah, you can just rewrap it. And I'm very wary of this because what rewrapper are you using? What is happening there? Please show me the files. I don't trust it. And YNOC4 says, seeing all of this makes me almost want to ditch my current Unity project and work on DOS. Keyword almost. As I've said before, I don't know if you were already there. The fun thing is it feels understandable because the architecture is so simple. Again, it's just when you want something on the screen, hey, you just put it in this memory because from this address, the video card will fetch all the bytes and push them onto the screen. And that's it. So if you know what byte to put where, you can do pretty much anything. And it's not something that you have to tell the driver, and maybe OpenGL will take care of this, or Direct 3D, and it goes through so many layers of abstraction where you don't even know what is happening, or yeah, it's just if you're not a full-time graphics programmer, you never even know what is all taking place before a certain pixel shows up on the screen. And again, with DOS, I like it because again, you're very close to the metal, and as always, you can pop in some assembly if you know how to write it. I do not, so this is why everything here is plain Pascal. Frank says DD is a tool to copy around data using blocks, which you can set the size of normally 250 bytes to copy floppies or something. Yeah, it's not a video tool, right? That's the thing. But if you use the right video format, suddenly one frame of video is a very precise number of bytes, and you can just use this sort of tool. And raw headerless 440 kilohertz 16-bit PCM audio has the same property. Because you have to know all these values. Essentially, you just punch in the hard numbers and to hope that there is not one sample or something has a header file still with it. And that sort of thing. Oh God, yeah. Recoil in horror, indeed. So again, I'm writing myself documentations here, like where I'm pulling certain knowledge from so that I can always look at it and hopefully understand it. +1 just to be safe. Oh, good old Phil. And apparently this +1 does not show up anymore. So again here, as I've said here, it's the ID3 tag. It's this metadata information. So if we have metadata information, we can just truncate it. So essentially we have this sandwich of, okay, there's the header. In between, there is our command data, which we are interested in, the command stream, and at the top is the metadata of artist and song name and so on. So we don't care about this. We don't care about the header. All we care about is the beef between the patties. I could go for a burger right now. So, and from this, finally, we know how large the actual buffer must be that we allocate. So again, pointed to raw OPL data. This is, we get the memory at whatever is at music, at data, and the data pointer will be the size. So we say, hey, please make me memory of this size and store the result, which will be a pointer in this field here on the heap in this struct. Then we go to data offset, because again, data offset, now we are here in the file. So data offset means we jump the first byte past the header. And from there, we just say, okay, whatever we have here, please read everything as a byte until we're out of bytes to read. So we already have here the size. which we calculated again. That's the meat between the patties. We start after the header, after the first patty, and go line by line, byte by byte, until we're out of patties to write. And this be written is just a safeguard, so I can just compare, okay, are all the bytes that I want to write, is this the same as the size, essentially? Because if not, there has been a problem somewhere. A burger of a refreshing sip of water, or a refreshing sip of water, perhaps both. Thank you, Cursible. And while I gotta head into work, thanks for streaming as always. I'll catch up on the WOD later. I wish you a wonderful day at work. Hopefully it's not too much. And yeah, thank you for checking out the WOD. And if you're watching this on the WOD, welcome back. So glad to have you. So once we're done with reading all the bytes from the file to our buffer, then we don't need the file anymore, we just close it. Again, always tidy up after yourself. So we're still here, this music data. Okay, now we know where the data is stored. So we got the pointer to this data, now we can fill out the rest. So the current position is 0, we haven't started this. The delay counter is 0, that we don't know any delays yet. And the size, of course, I think I already have it already, didn't I put? No, this is just, we just allocated a size, we get returned the pointer, and now I'm setting here explicitly the size of the buffer just to be sure. This is in the music data. In the music itself, we can say now the meta information about the entire track, that is, it is loaded, it is valid, it's not playing and it's not paused right now. And if we're doing debugging, then I'm just dumping here the metadata. So what is the offset? Where does the data start? At what byte? Starting from the header, and so on and so forth. And even have it here, dump the data as a text. Why did I do this? So that I can have here my hard-coded array. So essentially, this is when I run this, every file that I make ends up as an array of bytes, so that I can use for testing. This is what happened here. And it's reading a byte and writing it as a hex string, and writing it with 2 spaces, and also to screen. So not just to a file, but also to screen. By the way, if we want to look at this, yeah, if I run this is just a unit. This won't work. But is debug on? Oh, I've just duplicated it. Debug. Oh, by the way, of course, I switched off the music in the background. Debug value, do debug boolean false, let's say true, that it's being printed. And here in the game actually that we had, I have here this load OPL. So when I'm running this, it loads the VGM XLF. And this is exactly what I said, so that the size that the bytes written should be the same as the size and the size of the pointer. So this looks good. Then here just for myself that I can say, okay, end of the file offset, the GD3 offset, the data offset. So all good. I hit enter and this is the file. And it's again, just to make sure, I print this out because the last command should be 66, because 66 means, okay, it's over, this is the last byte. And by having this as the last byte, and okay, I'm not off by 1, where I'm reading already the first byte of the GD3 header, or I'm cutting off the last byte, which should be 66. So this is good. We're not hearing anything because it's not working there. But at least the loading works. So hopefully I can just copy this over, load OPL, and then just patch it up. So test data, can I collapse this? Yes. So we have OPL write. This is the low-level function, and play test data. And so I just pasted what I have here. And then we will see what problems we have. For example, I have here this data structure, which I do not have yet for music and data. So I probably need to have here the data as well for music and the individual files here. So I'm having here users, those are my constants, and my variables. Oh, not my variables, my types. So I have the type of VG music data and VG music itself, even here the type of header right now, which I'm not using. I'm just putting it in here just to have it just in case. And I think when I run this now, of course, I need to load something. So, oh yeah, I have one variable that is global to this unit. In this case, it's just called music, I think. Variable right here. It's var music because this is important. So again, this is like a static field if this were a class. So our static field is music because there can only be one music playing at the same time. So, and when I'm loading this and I'm saying play test data, I'm just saying, you know what, let's load a file name and we return a value of PVG music. We get the pointer to this and then we can say, hey, you know what, whatever is there, just play it. So VGM size data length. So this is the old function. So I'm just putting here an exit, which means it's a return function. So anything else does not run below here after this here. And so we say load OPL and the file name should be right. It doesn't know where it is right now. So I can, you know what, let me just copy this XLF file over here into the sources folder. No, but when I compile it, it lands in the bins folder. So it should go to the bin folder then. Right. So I'm not looking at this right now. So we're loading XLF.VGM. And what we get back is music. So music is what we load from, what this function returns to us. So since we're here in the play test data, then we exit. Right, okay. The automated unicorn is already amused by my attempts. So if I run this, probably a lot of errors. We will get lots of errors. Error opening file xlf.vgm. The question is why? Because I don't know where it was looking for it. So we're here in the bin xlf.vgm. Did I type it correctly? Yes, I did. Maybe it needs to go in the sources folder then. Let's give it a test. And thank you for feeding the automated unicorn. So, okay, apparently we don't get any errors. This is new. And it spits out just the data because right now it's not playing anything. It's just reading it to a buffer and then doing the debugging things. So I think I can take out our debug function. So load OPL. Apparently this really worked. So I copied all the necessary types and variables and so on. So again, do debug is false. Let's go with that. And so when I'm playing something, my play test data was essentially I did the counting myself and the parsing of the commands and so on and so forth. So I think let's do this, and instead of exiting here, so I have here my music. So we say here the VGM size is actually music dereferencing data dereferencing size. This should be, if it's typed correctly, the actual number of commands that we have there. And the data pointer to this should be not the address of the test data on the heap, but instead we already got the pointer, and that is music data pointer. I think I didn't call it pointer. What did I call it? Data pointer. Because pointer is a protected word. Data pointer. And hopefully this should already work. So I say here playing OPL data. I can also say write line loaded, and then I can just fetch the file name that I have. That is music dereference file name. Let's test. Okay, adlib detected, loaded XLF, and it should play it. Can I hear it? I did not hear it. Did you hear it? Let's mute the music in the background. Yes, it worked. It worked. And one test that we can do is just to load another music at this point. Maybe, you know what, maybe I will increase the delay to 24 just so that it's not that fast when it's being played back. Yeah, that sounds more likely. And you can hear it starts to loop again, but then it breaks off. And this is what I had here in my data where I manually set here, where I said, okay, 66 looks like the loop point, and $66, if you remember, this is the end of the song. So this is why I said, okay, probably here it should not loop, and just to have a smooth cut-off point. So, right, this was Axel F VGM. Let's try different music. I have here, I think, test 1 or 2. A test I've exported with Defle Mask, and this didn't work. And the other I've exported, it's a different shitty little music that I made in 10 minutes. And I think this might have been test 1. And you know what? Let's have a look at the hex editor in it. And I think this is the one that should work, because this I love about programming. This is something that I would have never thought that I would be able to 10 years ago. And the thing is, I'm looking here at a hex monitor and I know exactly what I'm looking for. And the thing is, okay, I know at offset 50, hexadecimal 50, there are 4 values. And when those aren't 0, this means that the OPL2 chip is targeted in this file here. For example, when I look at test 2 in the hex editor, here at 50 it says 000, which means this is not targeting the OPL2. So I know this is the wrong file, and test 1 is the correct file. And yeah, I don't see the matrix anymore. I see the things for what they are, and it's amazing. So what was it called? Test 1. So this should load a different music, hopefully. Apparently it's not a different. Is this the same? You know what? I have now I have to check. Is this really the same music? Did I just give it a different name? Because we load test 1 VGM. Well, let's listen to it in a different player. So here is my good old trusty foobar. So this is XLF. This is the actual speed at how it should be played, and this is VGM1. And yeah, it's the same thing. You know what? We probably should make a different song then, just so that we can see that actually it's working. Right. So where is my tracker? Korg M1 Furnace. No, this was Fami tracker. That's the wrong tracker. I have too many trackers. I love music, but I have too many trackers. Open recent. Oh yeah, that's not OPL. Yeah, screw this. Let's make a new shitty one. So just that we got something. So OPL2, and this is the Yamaha OPL2. Perfect. So we have here, do we have a default instrument? Let's make an instrument real quick. Yeah, I mean, this sounds... Yeah, why not? And maybe have another instrument so that we know we can have a polyphony. Yeah, and maybe one more. Let's try something like, I don't know, maybe something percussive. Something like this, so just so that we have something playing here. And as for the volume, okay, 3F, 3-0, 3F, 3-0, 3F. And we have a little bit of articulation there. Frank says, I remember you trying to claim you were not a programmer. It's gotten a little bit better. I still think that I'm no proper programmer because all of this is just hobbyist stuff and no other person or process is relying upon the quality of my code. So there's nothing at stake for me. So this is probably why I'm claiming, I'm not a real programmer. I'm just doing this for fun. So sounds like a news announcement. Maybe something that you would hear in, I don't know, Theme Hospital. Like, or let's make this a bit. May I have your attention, please? Patients are reminded not to die in the hallways. Thank you. Yeah, it works exactly for this purpose. So I export this now as a VGM file. I say we do not need a loop. It's just for this chip. And I hit export. And where do I put it? Where is, here source. And we call this stream 1. So that I know that we coded this in the stream, but it's also data stream. So we don't need to save this. He said before, regretting that he didn't save it. So let's listen to it in foobar again, stream 1. Okay, here it works. So this is my ground truth. And we say stream 1 here. And now let's play it in DOS. Fingers crossed. I think this is a success. And as I said in the beginning, so the first note takes a while to play. If you recall what I said, that it needs to transfer all these bytes to the hardware. So let's listen to it again so you hear what I mean. So listen to how long it takes after the first note to play the second. It has this little jerk in the beginning. I'm not sure if I like it. Again, maybe I can look into preloading the OPL music at some point. But for now, I think this is working. So I can take out the test data or data because I don't need it anymore. So next tests. Just the test length and test data I can remove, and hopefully let's see if it still loads or if I'm using these variables somewhere else. I do not. Good. And it's still taking a while because we can look at the file, why it's taking so long until it closes. But I just closed the tracker. Essentially, there was, in the pattern of the tracker, there was a lot of many rests, essentially, where the song was technically still playing. There weren't any notes triggered. So if I look here at stream VG music, we should have a lot of 62 bytes. And then a 66 at the end. So it's all 62. So this is one frame of rest and nothing else. So 62, 62, and then finally 66. And here at 47, when we look here at this, it already starts with GD3. So this is where already, it says here, our metadata starts. So Yamaha M3812, the OPL2, it was made with Furnace, chiptune tracker, and then end of file. Cool. So I love it when files look exactly how I think they should look. Okay, I would think this is some sort of success that I can load an arbitrary stream of data and have it interpreted correctly, in our case, as VG music. Okay, I'm already losing part of my voice today, but I would say read file from disk to buffer works. We play back the buffer, this works. play not from interrupt, this works. We did not play it from interrupt. Play test data from interrupt. We do not have the test data because I just deleted the test data. Let's hit the Control Z and there it is again, the test data. So I make this little donuts here. And yeah, the interrupt, I probably won't get into the interrupt handling. But yeah, again, and just having here references of how I did come up with this, of how interrupts are handled. So essentially the interrupt is our playback procedure. I mean, I can walk you through it. So one thing it says here, use the far pointer. And this is working apparently on Turbo Pascal, but not with Free Pascal, because it always tells me that this is not valid or not necessary here. And this might be the case why my interrupt is not running. But before even we can call the interrupt, we need to set it up. And this is probably happening here in the init OPL. So I'm just resetting the timers and so on. Play node, close APL. Those are my public functions. I think after loading OPL, there I'm setting things up. Because, like I said, we call the interrupt, but first we need to set up the interrupt. And I don't think I'm not doing this anywhere correctly. Because, again, you need to... Interrupts are actually triggered right from the system, from the BIOS. So essentially, I need to hook my own code into an existing interrupt, and I also need to change the interrupt that it fires more often. So here we have the interrupt ID. If I just look for the interrupt ID, there we go, start to playback. So when I start the OPL playback, I'm just looking for the pointer to the playback data. Then I set the music currently is playing. Then said, okay, the VJM now is our music data. Just it's a shorthand that I don't have to write music data every time. So we said the position is 0 and the delay counter is 0. Essentially play it from the top, set everything up that the pointer starts at the top. So then I have something here commented out, and it says, okay, get the interrupt vector of the interrupt ID, which is 7 of the original interrupt handler. And as far as I know or have read into this, what we have here with the original interrupt handler or the interrupt, where is my interrupt? So interrupt 8, this is of the system clock, the interrupt. And this is, the lower the interrupt is, the higher priority it is. And I think this is one of the higher priority ones. So we say, okay, whatever this is pointing at, this is called our original interrupt handler, because we cannot lose this. We need to store what the actual interrupt is that the system expects to happen. So then we say, okay, let's hook our own interrupt. And this is the address of the function OPL ISR. And then we just say right line ISR hooked. So when we stop the playback, then we say, of course, the music is not playing anymore. And we restore the interrupt handler to, okay, the interrupt ID was 08. And we say, okay, this goes to the original interrupt handler again because we stopped the music. The automated unicorn disagrees, but hey, that's just your opinion, man. So one thing that apparently I am not doing is I'm setting not the correct frequency for this interrupt handler, because you have to set, it's running at a certain frequency and you can only divide it by certain other values. So it's not like where you can say, hey, run this 60 times a second or 300 times a second, but instead you have to say, run this at a fraction of the original speed. And this is a value of 2 bytes. Which gets combined to a 16-bit value, and you have to write these bytes to a register in the chip first, and I think low byte first, then high byte. And I have this somewhere, and I'm not sure if I still have it in this file, because like I said, I tried so much, that's not working. So OPL interrupt test. This is just where I say, yeah, when this interrupt is running, so please write me at the current screen. So this is the actual screen memory. So whatever is there, please write there $3, which means I think dark green. Make this pixel dark green, and then increment this. So whenever this runs, it makes the next pixel thereafter dark green. At least this would have been the idea. So after my own test interrupt runs, it still runs the procedure that is at the original interrupt handler. So I have to first say, okay, this is a pointer, or this is of the type procedure, and then please run this procedure that is of type procedure there. And then, of course, once our interrupt is finished, we write the value of 20 to port 20. Apparently, this is to signal to the system, hey, the interrupt has finished, please carry on. Otherwise, it doesn't know that, you want to say, hey, the interrupt is over, please do whatever it was doing before, because the system is just waiting for the interrupt to finish before it does anything else. And one thing that I have where I'm not quite sure if this is okay is that the current interrupt handler that I have here is this big long function here where again it parses here the data stream. I don't know how to make this shorter, but again we're looking at, okay, should we write something to the port, and if so, yes. And we keep writing things to the port until there is a delay, and only when there is a delay we say, okay, we're finished here, and wait for the next time this interrupt is being called. At least this is what I came up with in this case. So okay, let's have a look at the original interrupt as I had it. Maybe there is a problem. So okay, the first problem that I already know is that I'm never specifying anywhere the frequency of this interrupt. So for all that I know, maybe this interrupt is running once a second or 20,000 times a second. I don't know yet. So interrupt is, we're defining here a type procedure is just a procedure, because again this is then the original procedure that we cast to. Never mind. So command and register, those are just bytes that we read. The VG music is the pointer to the VG music data, and P is just the pointer byte of the current byte we're pointing at. So only if the music is playing, then we get the music data to VGM. And only if the VG music delay counter is greater 0, then we decrease the delay counter. So again, we wait. So if this interrupt runs and we're waiting for the next note to be played, but it's not its time yet, then we just say, okay, the counter -1, and we say we're finished with the interrupt. I'm not returning here because this is why this huge else block here runs, because again we still need to call the original procedure, and after the original procedure has run, we signal the end of the interrupt. This must always happen. Right, okay, so if the position is greater than the size, well, then we're at the end and we just say, hey, stop the music, which also restores the interrupt handler. So this is why we were breaking out of this. I think this is good. Oh, Frank says, ooh, my chessboard is currently playing Turbo Champ, which is a recreation of Alan Turing's chess algorithm, which he never played on a computer, but he did play a few games by hand using it. Okay, so if your chess implementation can beat Turing's chess implementation, I have to raise my glass in admiration to you. I mean, you have the benefit of a much, much faster iteration, but still it's an algorithm thing, right? Then you can say your algorithm beat a Turing machine. Right, so to keep finishing looking through this interrupt. So okay, at this point there is no delay. We want to play the next note. Also, there still are more notes to be played. So let's fetch the command byte. So the pointer is the current data pointer. The command is the byte. So we're pointing at a byte, but the arithmetic is actually in 32 bits because we don't know in the heap how far this is, or has this already been mapped to a different memory page. I think this might be where the problem is. Anyway, so I'm taking the pointer that points to the start of our data and add the current position that we are. And then we just read this, whatever value this is, as a byte and increase the position. So now we have this byte that we've read as a command. Then we have here a switch statement. In this case, it's called case statement. So if the command is $5, well, or 5A, Well, then we say, okay, the next byte that we read is the register, and the byte thereafter that we read is the data that we send to the register. And then we call the OPL write, that just takes a register and the data and the port offset. In our case, it's always 0 because we don't have OPL3 playback, which would split these two reads between two different ports. Anyway, that is that. If it's of 5E, well then again, this is of an OPL3, so this is why we have port 0 and port 1, we can skip this. Then if it's of $61, it's a delay where we have a certain amount of samples before the next thing gets triggered. And again, here we increment the position by 2 because the delay counter is a 32-byte value. And otherwise, we would only increase it by 1. And if it's 62 or 63, again, those are just shorthands for delay counters. Those are fixed. Again, I'm seeing it now that this must be milliseconds here, this delay counter. And this might be the problem because in our case, it's more or less frames, essentially, because if this interrupt it's called like 70 times per frame per second, it means once every frame. And this one here is expecting, I think, milli or even microseconds. This can't be. So this is problem number 2 could be somewhere here where the delay count is just too big, and we're not even hearing the first note because I'm not waiting like 7 minutes or something running the program just to see whether this is working. But this might be a problem. So for debugging, I might set here the delay counter to 0 or 1, so just that I can know whether it's working or not. And if we encounter byte 66, it means, we're done, we can stop the playback. And otherwise, it's a non-implemented command. We're not caring about this. This is another thing that I've learned from when you're doing nestings. I always say, okay, what the end of is. So for example, I know that this third here is the end of the else case. If the delay counter is equal to 0, then whatever is happening in there. So this, again, I've learned the hard way. And whatever happened, once we're done, we say, please call the original procedure. I don't know why I need to do this casting, but I've seen this somewhere and it made sense. For some reason, I don't know Pascal, but again, it has to be with far pointer and near pointer, something memory management. And then we signal the end of the interrupt, and then we restore the compiler flags for the next part of code to the default. I think. Right, Frank says, it's playing at 2 PLY, I have no idea what this is. 2-player. So, one full move, which is what Turing did by hand. At least you don't have to calculate it by hand. It was draw by repetition. Oh, interesting. May need to change precisely how repetition happy the program is. Okay, yeah. I mean, now, at this point, it's tweaking, but maybe with existing algorithms that you already have implemented, maybe you can beat Turing. I'd say this depends on your tools. With Vim, I'm used to the percentage key bringing me to the other end of that block, so finding out is very quickly. Again, probably might be a tool thing, because I think it's also possible to have here, here I get here this waterfall of what things are, and when I hover over it, I see where the end is, right? When I hover over it and hold down Shift, it shows me here the line number of the end, and then I get here the comment of the end. So I could also write here the begin of where I'm currently in, but like I said, this is from my good old HTML days, where at the end of the diffs, when I had like this nested hierarchy of 7 diffs or something, I always wrote, okay, this diff here, this is the closing tag of the diff, which is of ID something. So 2-ply means 1 move by white and 1 by black. Okay, ply, a term is used for one player's move. Its originally meant something like a layer, like plywood. Okay, so plywood layer. Oh, interesting how some certain terms came up. So 2-ply means 1 move by white and 1 by black. I have to parse this. It's playing at 2-ply, so 1 full move, which is what Turing did by hand. Okay, so you're moving and then you're recalculating. This is what you mean, I think. Okay, anyway, it's after midnight, and I think I have some sort of success here that we were able to play something loaded from memory or from disk, put it to memory and have it play back correctly. Again, the one thing that's throwing me off slightly is there must be some overhead there, because the first note, we're transferring a lot of bytes there. We're parsing like 20, no, must be more, 30 bytes, and we're transferring this always to the audio card, which means, of course, when this is running as an interrupt, again, everything just has to wait for the first half second that this takes. And maybe at some point I need to look into how to do this with assembler. But again, this is another can of worms, because right now some of the management, at least the heap and everything, is done by Pascal, and I didn't have to understand it. And when I need to move bytes from one location in the memory and also make sure that when the interrupt is being called, as soon as I'm doing assembly, I need to somehow push all the registers onto the stack and make sure that I retain the current registers that are there. Otherwise, it's going to be a nightmare to debug, I assume. So yeah, maybe I get lucky this week when I'm trying to do this interrupt. But it was really helpful for me to do rubber ducky programming with you and just walk you through what is happening here with my interrupt. Like I said, I'm having two problems now. I think one is that I'm not really sure that the interrupt is set up correctly with the divider of the frequency. The next thing is I'm not sure if the interrupt is running. And the other thing that I'm not sure is if I'm reading a byte here, but I'm doing the calculation with 32 bits, and I'm not sure that whether this pointer, if this is correct, whether this point is not the end of this is already in a different page of memory, because we might be beyond the protected memory in DOS, which again is another big problem of worms, because if you go beyond 640 kilobytes, then you have a gap in memory, and certain bigger memories are paged in, and for this you need a memory mapper and so on and so forth. And again, I'm not even sure that my pointer arithmetics that I'm doing here, whether they work or not, or this is pointing at some memory that is not there, or I don't have any access to, or just garbage. Because if I don't have any access to it, then I'm not getting anything back, and since this is running in an interrupt, I'm not even seeing an error message there. So this might be another thing. And finally, the thing here with the delay counter, I'm not sure if for debugging I need to change this to some other values, because again, this is, I don't know where I copied this from, but this just says, yeah, this is for 60 hertz and this is for 50 hertz. I'm also, by the way, I'm not checking the rate, because again, this 50 hertz or 60 hertz again is somewhere in the VGM in here. I think must be somewhere around here. So what is this? This is decoded text. Anyway, yeah, I have to look at the specifications again. But yeah, this might be something to test for. So this really helped me a lot, actually, now that we are that I had you as my trusty companions in the depth of memory management on DOS. Frank says, it's used to say how far ahead you're thinking. Okay, now this makes sense for chess programs. Otherwise, like, you have this huge tree structure of all the possible moves. And yeah, doing this by hand might not be something that you finish as a living being if you do this for multiple moves ahead of time. Yeah, this makes sense. Right, so good news. I didn't get a migraine this time. So apparently Pascal is not that migraine inducing as I would have thought it is. It's still rather more complex than doing things in Game Maker and having the engine, the tool essentially take care of things. But like I said, it's a lot of fun trying to figure things out, and it's so rewarding, I feel, solving this puzzle of this is in memory at this address and I'm adding this offset to it, and look at it, it works. And you're thinking with pointers right now. And again, it feels like a new stage, new level unlocked in terms of programming. Thank you, Kersey, for redeeming Unicorn. And Yeah, as you said, yeah, debugging ideas. It's the worst when you're stuck and you feel like you've exhausted everything. It's a good practice to go through your code step by step and just look at, okay, this might be trouble, this could be a problem, and then just weed these things out individually. And as always, it's good old printf debugging, which is, yeah, you have certain breakpoints and where you print out certain numbers and you think, if I can read this printf statement, this means the code up until this point has run correctly or incorrectly, or I shouldn't be seeing this printf statement, and so on and so forth. This is how I do my low-level debugging. Right. Thank you, everyone, and I hope I see you next week. That will be probably Saturday. Our stream shall be, if nothing comes in between, because I haven't looked at my schedule next week, but it should be fine. And again, thank you everyone for being here. Thank you for subscribing. Thank you for redeeming your points. Thank you for sharing how many streaks you have in your stream. One streak too many. And also, I'm almost finished with my water. Thank you, Kersey Boo, for reminding me to hydrate. You? No? Okay, later. Probably. And yeah, I see you next week. Take care and yeah, have a wonderful week. Bye-bye.